Hello.
Hello. Hello. Good evening. Good evening all.
Hello, good evening.
Sir.
Yes, good evening.
So now only the class starting, sir.
Just wait for a couple of minutes.
Still the class is not yet started, no, sir.
We'll start by 8:10. Actually, I am connecting my device right now.
Okay, sir.
So, what's the today's this class schedule? Will we be taking doubts or it's a revision, conceptual revision session?
I will take your doubts as well, and basically this is a revision session for your quiz. This session will be for week 1 and 2, and week 3 and 4. The session for week 3 and 4 will be happen on, I guess, Friday, right? Friday morning. Vishal sir will take that session. Okay. Can someone please unmute themselves and then ask so that I will be aware, like, your voice is coming to me or not?
Yes, sir,
Yeah.
you clear.
Oh, yeah. Yeah. Okay, fine. The slides is visible to all, right? The blackboard, whatever it is. The
Yes,
screen is
Yes.
visible to all, right?
Yes, sir.
Yes, sir.
Okay.
Hello, sir. Hello.
Yes. 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 Yes, Vishal, tell. You want to say something? Hello. Am I audible, right?
yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. Now what's the time? 8:07. Okay. Just wait for 3 more minutes. Now, if you have some general doubt, you can ask. Okay. And by the way, how is
Hello,
going your
sir.
preparation for quiz
Hello.
for your
Sir,
qualifier?
good.
Yes.
Good.
Good. Okay. Okay. Yes. Someone was asking something.
Yes, sir. Sir, in this session we will discuss all those things which are in the week 1 and week 2.
Yeah, like it's up to you now. If you want some like explain me to some specific topic, I will explain that one. If you want to explain me the entire thing, I will try to cover the entire thing in the 2 hour session.
Yes, sir. Sir, if you
But
cover entire
yeah,
thing,
there
then
are
it will be
something.
better. It will be better.
What thing?
Sir, if you cover entire thing which are in the like week 1 and week 2, then it will be better for us.
Yeah,
Okay, week 1 and
especially
week
like
2.
week
Okay,
1 and week 4, since the weightage is higher.
week 1 and week 2, I guess.
Yeah.
Yeah, week 1
Yeah,
and week
week
2.
1 and week 2. Yeah, sir. Yes.
It's week 1 and week 2. Let me write here.
Sir, can I ask something?
Yes.
Sir, to just pass in max, week 1, week 2, if I learn that thoroughly, then if I'll be pass, if I get,
That how can I say? Like it depends on the margin of the question. Like what kind of question they are coming. If the like most of the question are coming from week 3 and 4, then it's difficult to pass, right?
okay, sir.
Sir, I
So
noticed that.
don't be like if I will learn from week 1 to 4. See, the thing is, don't sit in the exam just for passing the exam. Okay, just learn something from
Sir,
there.
you are not audible.
No, sir, you are audible.
You are audible.
Audible, sir.
Okay.
Sir,
Okay. So
I
what
can't
I am
hear
saying.
you.
Okay, now it's clear.
Yes,
Hello.
sir.
Okay. So the thing is, don't sit in the exam just for passing the exam. Okay, like it's not like that. You have to learn something from that. So, though it's a qualifier exam, but yeah, still don't be like that. Yeah, I will learn week 1 and 2, and then I will pass the exam. No, no, that thing is not going like that. Yeah, see, I don't think so. The question will be that much tough. Okay, the question will be slightly easy because it's a qualifier exam, not a end semester and all. So I don't think so. The question will be tough. Just see, you have so much of your time, like it's around 2 to 3 days you have right now. Okay, if you start learning from now itself, you can cover it.
Excellent, sir.
Also,
Don't
so
worry.
are the questions same for qualifiers and term students?
Sorry.
Questions are same for qualifiers and term students, or they are set differently?
uh, Questions will be definite differently, I guess. What do you mean by like qualifier is a different thing and the terms student are different thing, right? This is the quiz one as well as qualifier.
Yeah. So I'm asking for those it will be quiz for a few student it will be quiz one. Like for me it would be quiz one, and for a few students it would be qualifier. So
Yeah,
I'm
exactly.
asking
Who are just like those student who joined the ATM-BS program by this session only. Like for those student, this term is first term. So those student, this one is qualifier. And like if there is some student like who are opting this subject in their like second term or third term. So for that, this one will be quizzable. The question will be same, I guess.
okay,
Just
okay.
wanted to know,
It doesn't matter actually. Whatever question you will get, you have to solve there.
Yeah. So no, I was just asking, is there any difference in difficulty level for the qualifiers and quiz one students?
So same.
I don't think so there will be, but yeah, there may be possibility. It depends on the question to like I don't know what are the question they are going to ask. That's it. That's the
So many
thing.
questions were asked. Sorry to interrupt you. Actually, the quiz and the qualifier papers are same only. On the name is
Yeah.
changed.
Okay, okay.
um,
Okay.
excuse
Is
me,
there
sir.
any general doubt? Yes.
Question will be
So
asked.
just wanted to know which all weeks have more weightage for the exam.
Okay, what I will do in this session, I will like I will give some 5 star, 3 star rating kind of thing, which are more like what are the things are very very important for the thing. So basically if you see mota like relation functions are very very important for the quiz one. Okay, and for the quiz 2 I guess yeah, some lines, equation of lines, area, try like that parallel lines formula kind of thing, the angle formula, angle between two lines kind of thing. These are the thing very very important, like from week 1 just go through with relation and function. I don't think so they are going to ask any question from number system and all because it's a trivial thing. Like that thing you have already learned in the class 5 and 6 thing.
Sir, can you please repeat what and all important before 5 minutes you were telling, sir?
The thing is in the week 1 most probably the question will come from the relation and function part because if you will think properly like that number system part will already covered in your 5th or 6th standard. So I don't think so there will be some question from that number system part. Okay,
Excellent, sir.
even in this class I am not going to cover the number thing, like what are the rational number, irrational, but it's a trivial thing. Everyone is knows about it, right? It's just a wasting of time if I am going to explain all those things
Sir,
here.
sir,
Yes.
Excellent, sir.
skip all those things which are not necessary for quiz one. Okay, sir.
Yeah, I am going to skip that number system part, don't worry. But yeah, for
Yeah.
quiz one, most probably the question like will be come from the relation part, especially for equivalence relation, reflexive, transitive, symmetric thing. And for function, basically domain range, they can ask domain range and one function kind of thing, one onto function, surjective injectivity, or sometimes bijectivity. There is a very less property they are going to ask that countability thing. I don't think so. They will ask because the accountability thing is not mentioned in your like course. It's just a like supplementary thing that you have to just learning purpose only. So no, there will be no question from there itself. Yeah, for week 2, I guess most of the one question, most one to two question will be from SSC. Okay, that's some squared error, squared sum error, whatever it is. The question will be at least 1 to 2 questions from there itself, because it's a very important part from stats purpose as well. So question will be there from SSC as well.
Excuse me,
And
sir.
yes.
Sir, I just want to ask you, the question is ki, like I have learned and I have watched all the weeks content, week 4.
Okay.
And the problem with me is like if I'm dealing some problem, if I'm dealing with some question, at that particular moment, I'm not able to figure it out. Which formula should I use it? So I just
Okay.
want to take a suggestion that how should I approach the question, because I know every concept. If I'm just getting a little hint from anywhere, then I am able to
Okay.
think about that ki how question is solving, and I'm able to
Okay.
solve the problem, but at that particular moment I'm not able to figure it out how should I approach this.
Yeah, that's the thing, that thing is happened. So the thing is, for qualifier students, especially for qualifier student, I think this thing will work just like in competition exam, like, right? If you will score that much, then you can qualify the exam,
Yes.
right? 1/4 or 1/3, I guess, whatever it is. So
Mhm.
for that, why you are going to attend each and everything? That's my first question.
But sir, the marks is also included in for
That's
the.
the thing. But if someone is facing that kind of problem, so their first agenda is just qualify the exam and then somehow enter the exam, right?
Yes, sir. I got the
It's
point.
just like just getting a seat.
Yeah.
See, scoring is just another thing. It's just like if you are appearing in the UPSC exam and you just want to clear the exam. So what will be your first agenda? The first agenda will be you just clear the exam. After that, you will think about whatever rank I can get, right?
So, sir, like, how should I approach to this?
That's what I am saying. That's what I am saying. Whenever you are appearing for some exam, it's just like suppose you are a new person. Suppose I am the person, and
Mhm.
my father is very angry with me, and he just tell me just do whatever you want. I am not going to pay anything to you. Okay, you have to you have to arrange your food and all whatever you want. Okay, and what about me? My dreams are like I want to become Ambani. So what
Mhm.
will be my first agenda? I will be work for becoming Ambani, or I will be work for my food. Firstly,
No,
I
yes.
have to arrange for my food now. Then only I can think after that, right?
Yeah. Yeah, sure.
That's the thing. So the thing is, this thing will work for any exam. Whatever exam you are writing, if you are appearing that exam, so your first agenda will be just clear the exam. Once you are sure that yeah, I have scored that much, and now I will be clear the exam. Then only go for the attempting other thing. And I don't think so. There will be so much of question. There will be around the 10 to 12 question from Math 1, and same as for other 3 courses as well. So there will be you have 4 hours, and around like English 1. I don't think so. That will be so difficult, right?
Yeah, yes.
English 1, I don't think so. The difficult part will be for you guys, Math 1, and then stat, if someone has choose stat 1 and computational thinking and all.
Yes.
So that will be the difficult part. So you have to worried about that part. Okay. So once you clear the exam, once you clear the benchmark, then after that you will be think for the scoring thing. See, this thing is happen only whenever we are in hurry. Like we are like that. Yeah, I can choose this one as well, this one as that, this one as well. In that point of moment, I am not able to think what formula I can use. Right. So just relax, just be seated. If you know the concept, I know. If you will be free, it's just like what is difference between Manhattan distance and Euclidean distance. See, don't worry about that. The first one distance, you have to be the question will be asked for Euclidean as well. Euclidean
Sir,
only. Okay, Euclidean
sir,
distance.
can you please repeat?
The thing is, you have to think about the Euclidean distance only. Don't worry about the first one. Manhattan distance, whatever it is. Okay. So
Sir,
the
sir,
thing
I
is
have a general
don't.
doubt.
Yes.
Sir, is there minus marking for the wrong answer?
No, I don't think so. See, that whole the thing will be like, see, when the exam will start?
Sir, it's on 25th.
Okay, what is your no timing? Around 3 or 2 something, right?
Yeah,
2 to 6.
yeah, sir.
2 to
It's
6. 2 p.m., sir.
2
Okay, so
to
you have
6.
to
2
go
to
to the
6.
center
Yeah.
and yeah, you have to go to the center and then write the exam, right?
Yes,
Yeah,
sir.
yeah.
Okay, sir.
And what is the reporting time?
Two.
It's 1.
1
1.
p.m.,
1
sir.
1 p.m.
1
So
p.m.
just
Yeah.
go by 1 only. Okay, just go by 1 and then sit there and then try to relax. Okay, relax.
Okay,
And
sir.
there will be some instruction for related to the exam. Just read that. You will understand what kind of thing will be on. They will if there will be some minus marking. See, if someone is here for like who was who for those person this exam will be week 1, quiz 1. So they will know. Is there any kind of minus marking?
No,
No,
sir.
No,
no.
sir. There is not
No,
any
sir.
No,
minus
so
mark.
minus marking will not be there. So my suggestion is just go and just go with 1 hour before the exam and then try to relax yourself. Okay.
Okay, sir.
Don't
Thank
think
you.
too much about that. Okay. If you have worked hard, then you will definitely qualify the exam. Don't worry.
Sorry for the
Just believe in
interruption.
yourself. Yes.
Hi, sir. This is Abhishek here. So most of the
Yes.
people who are attending this meeting are specifically looking
Yes.
for three things. Number one is a blueprint. I mean, especially
Okay.
week-wise, what is a blueprint and what's the weightage we are going to get? And the second thing
Okay.
is, what are the important concepts that we need to focus
Okay.
on? And
Okay.
most importantly, we need some examples, some explanation related to that. If this
Okay.
happens in this session, it's going to be really helpful for each and everyone those who are attending this.
Okay, so I will try to cover all the three things. Okay, what if you are asking for blueprint? Sorry for that. I will not able to give any kind of blueprint because otherwise, what will be the difference between board exam and that kind of exam? So blueprint will not going to share with anyone. And yeah, weightage. I don't think so. I am going to share the weightage. Yeah, the important portion I can mention in the exam, like in the classroom itself. Like yeah, this is the 5-star rating question, like this kind of question they will ask. That I am already saying now. For the week 1, most probably the question will come from relation and function part only.
Okay, sir.
Okay.
Let's go.
Yes, sir.
Okay.
What do you mean by blueprint?
Yeah, the blueprint it's just like chapter wise, like in that chapter, how many marks are assigned for that chapter. There is no such kind of thing. Okay. So
I
blueprint is not. So don't ask
Sir,
any kind of thing. Otherwise, what will be difference between
sir, there was a
that board exam?
sir, there was
Yes.
a PYQ discussion in the morning. The TA
Mm-hmm.
said that it will be recorded and we'll have the video, but there is no video.
That
yes,
was revision session.
They will upload after some hours and yeah, yesterday
Okay,
in
okay.
tomorrow.
I will let you know then. Okay.
Yes, please.
Sir,
I
for
will let you.
week 1, they will ask relation and function or
Yeah,
only
most
set
of the question
functions.
will be. Yeah, most of the question will be confirmed there. So, okay. So what you want? You want me to write in the board or you want me to like explain by a slide? I am comfortable
Sir,
with
Right
both.
on the
explain
board.
by slide.
Okay, explain by slide. Okay.
yes,
Sir,
sir.
right.
Slide will be faster.
Sir, right on the board is very clearly to understand all the concepts.
Now, how will I
Okay, sir,
work?
right on the board. Okay, sir.
Yes,
Sir, I
sir, right
have
on
a
the
Not
board.
doubt.
able to see the slide. Okay, I will do both thing. Okay, here I can write or not. I don't know. I am not able to write here. I will try. Okay. No, I'm not able to write. So basically, see this part I am going to exclude this natural number, integers, rational number, whatever it is. You can easily read and understand the things, right?
Yes,
Yes,
sir.
Okay, so I will start from the relation as well only. Okay. Is it fine
Yes,
for,
sir.
okay,
That is
what about the set thing? Okay, let's start with set. Okay, yeah, question can come from set as well. I forgot the thing. Okay, so basically let me write for week 1 important thing. Okay. Okay, let me see what other things are there for.
You said counting questions will not come. What do you mean by counting
Yeah,
questions?
counting
Sir,
question
sir,
is
can
that
you take some
there are
examples of Venn diagram here?
Venn diagram.
Yeah.
If you have some example, we can solve together.
Okay, sir. I will do.
Please arrange.
So will you share these slides?
Yeah, I will share. Don't worry. I will after the class, I will pay upload the slide on the chat box itself. You can download it from where there. Okay.
Yes, the clarification about the counting questions.
Okay, so counting question will not going to come because that will not included in your syllabus. It's just a reading purpose only or learning purpose only. Okay, that countable thing, na, you have learned that countable thing. Natural numbers are countable, real numbers are not uncountable, that kind of thing in the last of the week.
Okay, but the countings inside the Venn diagrams, like how many elements are there in this set, those are there, right?
Yeah, those are. It's easy. Just.
Sir, counting
Okay.
of prime numbers and everything, all those kind of questions.
Counting kind of thing, I don't think so. See, they can ask like that kind of question. Okay, so let me ask. In the set theory itself, they will ask like that. Suppose set A have something. You know this. You are aware about this formula, right? Number of elements in A union B.
Yes, sir.
Number
Yes,
of
sir.
elements in A.
Yes, sir.
This one.
Sir.
Most of the question will come by this formula only. Okay, and another one is there. Number of element in A union B union C.
Sir, can you
is
write
equals
and
to.
show that formula?
Yeah, I am writing now. You can
Your
see.
slide is not
We can't
visible.
see. Yes, sir.
Oh,
Yeah, your screen is not visible.
okay, sorry. I thought like I have shared the screen. Now it's clear. Now it's visible. Thanks for
Yes, sir.
reminding.
Yes, sir.
Yes,
Yes,
sir.
yes.
Yes, sir.
Okay. So are you aware this symbol number of set S, or sometimes we are using this one, or sometimes we are using this one?
Yes, sir.
Are you aware about this? It means that the cardinality of set. Cardinality. Okay. So plus, hey, you can find in the internet as well. This formula is very famous. What else? Number of element in A intersection B.
B intersection C. B intersection C.
B intersection C.
C
And
intersection.
number, yeah, C intersection A. Then addition with number of element A intersection B intersection C. Okay, so basically what kind of question they will ask? They can say, yeah, in a town there will be like 70% people, like that kind of question they can ask. There will be 70% people who is watching TV, who is like to watch like to read newspaper, who likes to read newspaper. Okay, there are 30% people who likes to read book. Okay, this is just an example kind of thing. Whatever whatever I am coming in my mind, I'm just telling. Okay, and there are 40% people who likes to read comics and all. Okay, so there are three kind of people. So this is set A for reading, like 70% people are reading this newspaper thing. This is set B and this is set C. So what are the basically? This is set A for newspaper, set B for what's that?
Book.
Books.
Comic,
Yes.
Books.
Books only. Novels, or you can say novels. Okay, whatever it is. And this is set C. Set C for
Comics.
see, don't look at the size of the sets, okay? It can be anything. I am just writing for giving you the intuition only. So this is for 70%, this is for 30%, and this is for what? 40% for comic book and all. Okay, so they will say, and again they will give you another reference like how many peoples are likes to read both this A and B, and they sometimes they likes to be. So basically what they will give the information of 1 2 3 4 5 6, like most of the thing will be there. Only they will say, they will ask for what are the, like how many number of people, how like in what percent of people, like how many people likes to read all of the things. So if they will ask all of the things, it means that you have to find this intersection, A intersection B intersection C. Sometimes they will ask for B intersection thing. Okay, so you can use this formula and then you can evaluate the thing. Okay, so here 70% thing means, suppose in a town there will be 100 people. It means that 70 people likes read book, 30 people likes read something, this whatever it is, 40 people like this, and accordingly they will say, yeah, A intersection B will have some people, that kind of thing. You are getting my point, what I am trying to say. I am not solving a question here, but yeah, I am giving you the intuition what kind of question they will ask. Okay, this is the most common question is asking. In a JEE advance also they will ask, like they will twist this question in a very different way and they can ask like that. Okay, so these two formula are very, very important in the set. There is a very
Sir,
strong
by
possibility
using
that
these
one
two
question will
formulas,
be.
we can solve set theorem easily, sir.
Yeah, exactly. If they will asking for a count number of student and number of whatever it is, okay. If they are talking about the cardinality thing, there will be a strong possibility that one of the formula from these two will work. Okay.
So we can also solve this problem by using Venn diagrams, right?
Yeah, you can solve by using Venn diagram, but checking Venn diagram is really difficult. Okay, why it's really difficult? If you are checking with the, like if you are working with the small concept, like there, if they are only 10 people, then it's easy. If there will be around 10,000 people, then how will you check?
Okay, sir.
Okay, so working with Venn diagram for a less number of people, it's easy. I'm not saying, yeah, it's easy. But for the large number of data, it's very difficult. Okay.
Got it.
That's why I am saying now, just go with that. Okay. These two are very, very important in the set theory.
So I have a
Okay.
question. In case like they
Yes.
ask that like what is the cardinality of A or B? So in that case, are they meaning A union B?
A or B. They will not going to directly ask what is the cardinality of A or B. They will say how many people are there who are reading, suppose in this example only. So they will say how many people are there who are reading either book or either newspaper.
Yes.
It means that they are using this both up. They are trying to include both things. Okay. So once you will read the you will read the statement, you will be able to figure it out what they are actually asking.
So in case of either A or either B, they are basically meaning A union B, right?
Union, exactly. Or in case of AND, they are trying to ask for intersection B. Okay. So basically, OR thing is used for union and AND thing in general. Okay. AND thing will use for intersection. It's also depends on the question as well. But yeah, if you will read the question, I don't think so. Like there are some people who have some problem in reading English, right?
Yeah, of course.
Yeah. So if this is the case, then you will be easily figure it out what question is asking.
Sir, if
Okay.
it is at least also, then it is also union, no?
At least, can you say the statement what is exactly?
Like number of the students who are at least have taken one subject.
At least has taken one subject.
Yeah, who have taken at
Yeah.
least one subject.
Yeah.
So it would be union.
Okay, it's just like,
Sir, how it can be union?
no, it will not union. Yeah, that's the thing.
So why at least is there, so it will be
Oh,
used.
what? See, let's do it by example. Suppose A is there, B is there. These are all the set. Let's try to form the question. Okay, these all three set. Okay, we are saying there are 10 students in this set, there are 20 students in this set, there are 30 students in this set. Okay, so we are saying number of, like, these are the member of some committee, whatever you can think, you can. Okay, so what's your question is how many students are opting at least one subject, or how many students are inside at least one set. So yeah, you are asking for the union only. Okay.
Yes, sir.
Sir, but they will ask like 20 students from A, 20 from B, 10 from C, and then 15 from A and C, and then 5 from A and B. They will ask like that. No, sir.
Use
Yeah, but the
formula for
thing
this.
is, yeah, for this you have to use the formula. You cannot directly add the thing. This formula you have now.
Okay,
Intersection, the intersection thing, they will definitely inform you. Okay. If they are asking for one specific thing, all the thing will be given in the question only. And one more thing, if they are asking for cardinality of A itself, they will say how many students are there in A only. Okay. That kind of question will be there. Got it?
Sir,
Got
can
it?
we solve some PYQ questions from this
I
topic?
think PYQ question is solving by the that is right now. I don't have PYQ. That's the thing. That's the another thing. But most probably TS session are going on for the PYQs.
Yeah, tomorrow morning there'll be one.
Yeah.
Okay.
So see, the thing is, please attend that session because PYQ are more important. Like you can get the idea what kind of question will become.
Yes, sir. If you can just provide us a recording of the previous session that happened today morning, because there was a clash between stats and maths.
Okay. Okay. I will tell them for that. Okay.
Yeah, sir.
Okay. Shall we start the session because it's already 8:37.
Yes, sir.
Okay, sir.
Okay, so let's start with sets. Okay. So what is set basically? I have already tell them in the very first session, my first session. I have give you the basic idea. If you haven't watched, I am suggesting you please go and watch that session. If you want, you can watch in the 2x speed. There I have given very very deeply. Okay. So what is set basically? Can
Sir,
someone
where
please
can I find that?
unmute? I think it's the second revision session.
Yeah, where can I find it?
On
You just go
YouTube.
to the website. Sorry, not
IITM.
website. A YouTube channel you can find.
Sir, can you please send that link?
I don't have that link right now. I have
Search
to search on
IIT
the Google.
Madras on the YouTube and you will able to find that session.
Yeah. So can someone please send the link on the chat box? Okay, so let's start. Okay, someone will send the link. Okay, or you can go through the calendar now. Just see the second revision session. You will find that. You will find the link on the calendar as well.
Okay, sir.
Okay, so set, what is set basically? It's a
Collection of elements.
well defined
Well
collection
defined
of objects.
collection of
Well
objects.
defined of object.
Well defined collection of object. Everyone is aware about this, why this well defined and why this collection is coming, right? If you are not aware, I am again saying you please go and watch that lecture. Okay, because this, I think for explaining this thing I have taken around 15 to 20 minutes. Why this well defined words is coming here, why this collection words is coming here. Okay, so here I
Yeah,
am just
sir.
writing the definition. I don't want to repeat it again. It will take too much of your time and I don't think so the definition will be helpful in the exam. Okay, so set is what? Basically, it's a well-defined collection. And then after that, the subset thing will come. Okay. Subset is what? A is said to be subset of B. if and only if what
A is equal
for
to
all elements which are inside this A, this implies X has to be inside B. This is the definition of subset, right?
yeah.
Yes. This is the definition of subset. What does it mean? It means that if you have a set B, okay, this is your bigger set. It means that this A is what? This is just a part of this set, like this. Getting my point? Right?
Yes, sir. Clear.
Right? Okay.
Yes,
So
sir.
after that, what are the things here? Set, subset. Okay, then cardinality comes into the picture.
Sir, please explain a proper subset also. What is the difference
Okay.
between yes,
Okay,
sir.
I will. Just a minute. Okay.
Okay, sir.
Okay, okay, so here, okay, during the class, please remind me if you have some doubt, please stop me there itself. Like someone has doubt in super subset, proper subset, and subset, right? Okay. So what is proper subset basically? Proper subset, it means that, so see, here if we are asking about this thing and we are saying for all elements which are in A, it has to be inside B, right? But there is a possibility that, see, suppose in this set, I have 1, 2, 3, 5 element. 1, 2, 3, 4 element. Okay, this is my set A. Okay. Now, if you are able to see, just see that here for all element which are in A, this implies this X are inside A only, right? This thing is happening here, right?
Yes, sir.
Or if I will give you the another name of this set, then I can see that for those elements who are inside A, they are inside B as well.
Yes, sir.
Right? And another thing is happening also here. For all X element which are inside B, this implied that this X is inside A. Right?
Yes, sir.
Right?
Sir,
Right?
I
It
can't
means
understand.
what?
Can you please explain once again?
What I am saying, see, this is my set A. Suppose this is my set A. Or let's take a different example. Suppose this is my set A, which has 1, 2, 3 elements. Okay, these are the element 1, 2, and 3 in set A. And this is my set B. It has also 1, 2, and 3 element. Okay. From if you are able to see, both sets are equal, right?
Yes, sir.
Right?
Yes, sir.
Both sets are equal. There is no difference between both sets because it has 3 element name as 1, 2, 3. It has also 3 element name as 1, 2, 3. Both are same. Right? Both are same,
Yes,
now?
sir. Yeah.
Now, observe one thing. What is the observation here? The observation is that for all elements which are inside A, okay, just like 1 is inside A, 1 is inside B as well. This implies that elements inside B, right? 1 is inside A, 1 is inside B as well, right? 1 is inside A, it implies 1 is inside B as well. Similarly, 2 is inside A, 2 is inside B. So I can write it as like this now. For all elements which are inside A, this implies that X are inside B.
Sir, this can be named like union also, no, sir?
Not union. This is the different set. This is the different set. Okay. It's just like suppose there are 2 rooms. Okay. There are 2 rooms. And here I have a set A. Suppose I have a bag kind of thing. And in that bag, I have a number from 1 to 5. Okay. In this bag, I have number 1 to 5. Similarly, here I have a bag. And in this bag also, I have a number 1. I have a number, suppose 1 to 6. 1, 2, 3, 4, 5, and 6. Okay. Now, observe that here A is not equal to B, right? Because here one more element are there, which is 6. Both are separate. Both are sitting in the another room. Okay, so both bag are separate right now.
Yes,
Okay.
sir.
Okay, please give feedback so that I can give answer whatever I am
Yes,
Yes,
asking
sir.
right now.
Yes, sir.
Okay, so that I can follow you. So both sets are not equal because 6 are not inside A now. If both sets are equal, then each element has to be equal to each other in both set A and B.
Yes, sir.
When we will say
Yes, sir.
both set are equal, then only now if each elements are equal to each other.
Every element of set A is equal to the every element of set B.
Exactly. That kind of thing happen. It's just
Yeah.
like 1 is there, yeah, 1 is there also. 2 is there, yeah, 2 is there also. 3 is there, 3 is there also. 4 is there, 4 is there also. 5 is there, 5 is there also. But what about the 6? 6 is there, but 6 is not there in A. It means that it cannot be equal to each other.
Yeah.
Yes, sir.
Right? Right? It means that they are not equal to
Yes,
each
sir.
other. But what is the observation here? Observation is that what are the element if X is inside A, what are the element which are inside A? These elements are inside B as well. Right?
Yes, sir.
What are the element which are inside A? They are inside B as well. Right?
Oh.
So in this case, we will say, yeah, A is a subset of B. Okay.
Mhm.
Okay. Now just remove this 6 here. If I will remove this 6 from this set, or if I will I will assume the different set, okay, then if there is a possibility, like in this case, if I will remove this 6 in this set, what are the elements which are inside B? They are inside A as well.
Yeah,
Right?
both sets become
Both
equal.
set has same. So in this case, both sets are equal, right?
Yeah.
Right? But still we can say now, we can say like that A is a subset of itself.
Yes,
A
sir.
is a
Right?
subset of itself. Yes, sir.
Yes, sir.
A is a subset of itself by the definition. What is the definition of subset? The definition is saying if A is a subset of B, then for all elements which are inside A, that element has to be inside B. But if I will consider here A as well, so every set is a subset of itself, right?
Yeah,
By the
yeah.
definition.
Yes, sir.
Right?
Yes.
Okay. So for excluding this subset property, like there is a possibility that if A is a subset of B, there is a possibility that A has to A is equal to B.
Sir,
This
can
is the
I tell?
possibility, right? Yes.
To be simple, all the elements from both subsets must be equal or the same, then it's proper subset.
No.
Am I right?
I am explaining. No. The thing is, see, if something is a subset of B, what are the possibility? Two possibilities are there, na? Either both set are equal, or there will be some element in B which are not inside this A.
Yes,
Right?
sir.
It means that for all X belongs to A implies this X belongs to B. Right? Either both sets are equal, just like this case. Either both sets are equal, or there is a possibility that there is an element in B. In this case, that element is 6, which are not inside A.
Then it's not a subset, no, sir. Proper.
It's a subset. It's a subset. Now, what is the subset definition? If I am saying A is a subset of B, what I am saying? If A is a subset of B, it means that for all element, I am checking each and every element. I am picking one A from here, and then I am seeing whether this one is inside B or not. Okay. Then after that, I will pick 2 and then see B 2 is there or not. Then I will pick 3 and then check 3 is there or not. If all the elements who are inside this A are there inside in B, then I will say, yeah, this A is a subset of B.
Sir, then when will A will be the proper subset of B?
I did not explain the proper thing right now. Okay. I am just explaining subset thing. So subset thing is clear to everyone, right?
Yes, sir.
Just let me know
Yes,
first.
Yes,
Subset thing is
Yes,
clear,
sir.
everyone. If I am saying
Yeah.
A is a subset of B, it means that what are
all
the element
elements
are inside A?
are the
All those
elements of
element
B.
has to be inside B. Correct?
Yeah.
Yes, sir.
Yes, sir.
Correct?
Got it,
So
sir.
what does the proper mean? Okay. So if A is a subset of B, there is a two possibility. First possibility is that either both sets are equal, or there is a possibility that there exists an element x naught inside this B such that this x naught is not inside this A. These two possibility are there only, na? Right?
Yes, sir.
Right?
Yes, sir. Yes.
Either both set are equal, or there exists an element in B which are not inside A.
Yes.
Right? So in this case, if this case is happen, then we will say this A is a proper subset of B. Okay.
Can you repeat?
What I am saying, if this case is happen, like if you are getting at least one element in B which are not inside A.
Okay, sir.
Firstly, what are the condition will given? They will say, yeah, A is a subset of B. Now you have to check this is proper or not. For this definition, this thing is whole. It means that for all element which are in A, it has to be inside B. It's just like this is your A, this is your B, and this is your A. Okay. This is your A. So this is one element which are not inside A. If you are able to see, all the elements are A is also elements of B as well, right?
Yes, sir. Yes, sir.
Right?
Yes,
But
sir.
there are some elements which are inside B, but they are not inside A in this case.
Yes, sir.
So in this case, we will say A is a proper subset of B. Okay?
Yes, sir.
But there is
Okay,
a
sir.
possibility that
Got it.
I am saying this is A my, and this is also B. I am saying this is also B. In this case, A and B both are equal. Okay?
Yes, sir.
Yes,
So you
sir.
understood the difference between
Yes, sir.
proper and what is proper
shall
and what is actual subset? Yes.
Let's show the
Yes,
show the
sir.
previous
It means,
example.
sir, if A is equal to B, that is
Then
A,
it's
it
subset.
can be the
This
subset
is
of
just
B, but it
you
cannot
will
be
say
proper
just
set.
the proper definition is saying you at least there exists at least x naught. There exists an element in B which are not inside A.
Okay, sir.
It cannot be equal to A. Okay. Simple thing. If you are using proper word is here, so it means that it cannot be equal to B. Simple.
Clear, sir.
It means that discard this possibility.
Sir? Always A is a proper subset of B if A is not equal to B.
Exactly. No, if A is kind of satisfying this condition, then we will say like.
Okay, sir.
Okay.
Yes.
Yeah, sir. Can we move to the
When
Sir,
next
if
topic?
we
we will be dealing with
Yeah,
proper.
because this topic will not come in the exam. I'm
sir,
sure
if
because
we
this is the 9th topic.
Sir,
Yes.
it's take too much
just a
time.
little question.
Yes. Yes.
Sir, when we say prime number is a subset of natural numbers, so can we
So,
also say that prime numbers are the proper subset of natural
yes,
numbers?
exactly. That is the exact
Okay.
example for proper subset because
Yes.
one is not a prime number, but one is inside the natural number, but one is not
Yes,
inside the prime numbers.
prime
Okay.
numbers.
So
Okay.
prime numbers is a
Yes.
proper subset of natural number.
Okay,
Okay.
sir.
Let's
Thank you.
move.
Got it. Thank you.
Okay. Then cardinality. What is cardinality basically?
Number
Of
of
element
elements in a set. Yeah.
number of element in a
set.
known as cardinality of A. Or sometimes we will denote it as like this, and some people will use like this. Okay, these are the notation. You can use any, but most probably you can prefer. Yeah, one more thing is there. This one is also. Usually I am preferring this one. I don't know. In the exam, what kind of like notation they will say. Okay, what are the notation is using in the lecture? They will use that notation only. Okay, but you will be aware about this four. Okay, so cardinality is done. Then substance is done. Empty set, yes.
Sir, how do we represent an empty set?
Phi.
Phi. Like in set form?
Sorry.
In set form, in set form, there will be no elements. Just we'll
Yeah.
put
Empties
curly
means
braces.
what? There will be no element.
Yeah.
Sir,
It means that collection of all the people who has tails. Empty, no?
Only
sir, what?
curly braces will be there. Inside. We won't put 5.
Sorry.
We just
This kind
represent
of
it
thing.
by fire.
Yeah.
Yes.
See, don't confuse in the notation. Okay. This is just an empty thing. Simple.
Okay.
Okay.
Sir,
Yes.
cardinality of expression is written as 2 to the power n.
No. No.
If
That is
there are
coming from power set.
if 5 elements
Power
are
set.
there in a
And
set, if 5 element in a set, then what is the cardinality of set?
5. Cardinality are what? Number of element inside the set only, no? That's the thing. Simple.
Sir, I think he is asking about A cross A, like S cross S. So he was saying.
Yeah, that I will explain. No, don't worry. That I will explain. Let me explain. Let me go forward first.
Okay.
I will cover each and every topic. See, if you are not like aware about it, I'm again telling you, please go and watch the previous lecture, because in the previous lecture, me and Vishal sir has covered each and everything from the scratch. Okay, we did not like exclude any topic. So please go and watch that lecture, because if I will go in with this speed, I don't think so I can cover every topic by
Yes, sir.
12
Cover the
o'clock
most
itself.
important
Yes, sir.
topic.
Yes,
Sir,
sir.
if you can please copy that link and send
You're
in
right,
chat.
sir.
Okay. Right, no? So where is it? Okay, this one. So it's better I can go with the PDF itself. Okay,
Yes.
so these are the things are clear. Nothing is there. Okay. Here I am not able to write actually. That's the thing. Otherwise I can explain here itself. Okay, so what is set comprehension is what everyone is aware about set comprehension, sir?
Yes, sir.
Yes, sir.
Yes.
Okay, no need to explain. It's just the definition of set, like how we can represent a set. That kind of thing. It's just like if I want to represent my family, how will I represent? I can say, yeah, this is my family. I can say like that, na? Or you can like you have heard about that, like in the 90s movie, there will be one term like most probably Amrish Puri. Have you heard this name, Amrish Puri?
Yes, sir.
Yes, sir.
Who was villain in Gadar?
Yes,
Gadar
sir.
one,
Yes.
I guess. Yes. So
Yes, sir.
he was like there was some Jaminda kind of thing and Thakur kind of thing. Have you heard about it? So how will you represent that Thakur family? You will say, yeah, this is the Thakur Parivar. Have you
Yes.
seen that movie like Suryavanshi, whatever it is?
Yes, sir. Yes,
Like
Yes,
sir.
sir.
Amitabh Bachchan, that was the Thakur Parivar, no? That
No.
kind of, so how will you represent that kind of thing? That representation thing is known as comprehension. Set comprehension form. It means that every set is always follow a rule. If I will like define that function via that rule, then we will say, yeah, this is the definition via comprehension part. Okay.
Sir, it is also called as a set builder form.
Yeah. Set builder form and set comprehension both are same.
And
Okay.
roster form is what we have discussed so far.
Yeah, roster form is just like introducing each and every element. It's just like if I want to introduce my family, how will I introduce? There are two ways. Either I can introduce one by one person, like I will say, yeah, this is my father, this is my mother, this is my sister, that kind of thing. And the another thing is I can say, yeah, this is my family. Both things are there. So the first thing is known as roster form. The second thing is known as set builder form or set comprehension form. Simple.
Yes, sir.
Okay, so power set. Power set is what? Power set is nothing but power set is just the what? It's just a collection of all the subset of set. Okay. Power set is what? If you have a set S, then power set is denoted by this PS. This is row, okay? Okay, don't use this symbol here. Otherwise, you will be confused what is the cardinality symbol or what is the... Okay, don't use this one. This 3 is sufficient for you. Okay, so power set of S is denoted by this symbol, and this is what? All the subset of S. Okay?
Yes, sir.
You know now, if S is a set, there will be some subset. Collect all the subset of S. It's just like if you have a set like 1, 2, then power set of this is your S, then power set of S is what? What are the collection? Firstly, empty set is a subset of, then set S itself, then take singleton.
And then one set 2. Yes.
It's only, right? This is all the set.
So
Empty set, the set is itself, this S is contain this 1, 2, no? This both. And okay, for you, let's say this is equal to 1, 2 itself, no? Both are set. Then singleton one. Okay? So this is your power set. And how many elements are there in power set? If your set S, number of element in set S are n, then number of elements in power set PS is what? 2 raised to the power n. Okay?
Yes, sir.
Now,
Sir, and
what's
then,
next?
Sir,
Sir, I have a doubt, sir.
Phi will
Yes.
also come under curly braces.
Why phi will come under curly braces?
Sir, in the slides,
This is not empty set. Empty set is this. Okay, this is empty set. The cardinality of this set is 0, but the cardinality of this set is 1 because there are one element phi. Okay,
sir.
Yes.
Okay.
Okay. I don't know about the slide, but that's the thing. It means that this is a singleton set. It means that the cardinality of this set is 1, or in case of empty set, the cardinality of empty set is 0. See here also, this is incorrect.
Sir, if a set have 1, 2, 3, 4, 5,
is
what is the cardinality of set, sir?
Sorry?
It is 5 or 6, sir.
Sorry.
Sir, if
1, 2, 3,
3,
4,
5.
4, 5.
No.
This
5.
one.
5.
Sir, it's 5.
Yeah, 5. Yes.
Then cardinality of this set is
5 or 6, sir. Sir, why we are not include the 5 in find out the cardinality?
Phi is what? It's a set, not the element of this set. It's a itself of set, or you can say it's a subset of this set. What I am saying?
Okay.
What I am saying? I am saying cardinality is what? Cardinality is number of elements which are inside the set. Okay. This phi is what? Does I have written here phi as an element? No, right? No, right? Phi is a subset of S. Okay. Subset of S, being a subset of S and being an element of S, both are different. Don't mismatch to each other.
Okay, sir. So what is the cardinality of empty set?
It's 0 now, because nothing is there. If nothing is there, how will you count? What are the things there?
Okay, sir.
Okay.
Sir, one
Let's
doubt,
go.
sir.
Set operation. Yes.
Where is phi used practically in real world, sir?
Phi used practically in real world. Suppose I will say how many students are there in IITM BS program who have 4 legs.
Sir, this is
What
not
will your answer?
4 legs.
Just collect all the elements from IIT BS program who have 4 legs.
This was the best example.
There will be no 0, right? Now, how will I represent that thing in my computer? I need some representation for that, na?
Sir, let's proceed to the questions with more weightage, like the topics with more weightage.
I don't think so. Whatever things is cover, they are going to coming to the exam right now. This trivial thing you have to ask in the very first session, right? Where you have too much of time and you can bother about each and every small thing. But in that session, that's your big mistake. Like in that session, you guys are not asking anything. You guys are just keeping a finger in your mouth and just watching just like a movie. You have to ask in that session.
So can you please take this exam point of thing so that we get more clarity?
Yes. Just go and watch the lecture. That's the thing. Now you have to watch the lecture first. Okay, this formula I have covered, right? I have explained this formula in the very early in the class.
Yes, sir.
Yes.
Okay, let's move. Cartesian product. Cartesian product is what? A Cartesian
Sir?
product. How this light is working, I don't know. Just touching and then moving forward. Yes. Yes. Yes, Aman,
Sir,
you are
sir,
yes.
if elements in a set are not defined with a common property, then it is not a set, right? Then if we do any operation between two sets, then the resultant answer will not be a set because we can't define it.
It will be a
Uh,
set. Now,
like
why we can't define? If you are operating to set, it will be a set.
yeah.
Okay.
But how can we define the answer? Like if we do here we have taken a is equal
Just
to
write the operation. Just write the operation. Yeah, you have two set and you are doing that operation. By that, you are defining a set. Whatever result you will get, the result will not be same, right?
okay. Let me take this example here. It's given a is equal to a comma b and b. Sir, in the previous slide it is given like b is equal to 1 2 3 4.
Bro, these questions won't be asked in the exam. We are wasting our time.
Sir, I think they are not watched the previous lectures that you have.
Okay, so the thing is,
Sir, I have watched
just
them.
please
That
go. You have watched? Okay, what's the doubt? Let me take the doubt, please. Don't worry, I will finish all the thing. If the class will happen from 1, I will take. Don't worry. Okay, what's
Let's
the
take
doubt?
b is equal to 1 2 3 4.
Okay. A is equals to 1 2 3 4. Then
b is equal to a comma b.
A comma B. Then
Then if we take a union b, which will
A
be a
union
comma
B.
b and 1 2
Yes.
4, then we have to define this a union b with a common property on all elements, right? Then only it will be said to be as a
How
set.
will you define this set? You can
Then
directly
how?
write it as like this now. S is equals to for all X element. For all X such that either X are coming from A or X are coming from B. That's it. This will form this set only.
Then what if we do multiple operations?
Whatever operation you will do, you have to write like that only. If you take an intersection for some other set, you will say this and whatever X has to belongs to this. Or you can directly write it as X such that X belongs to A union B. Simple. It's already exactly equal to this.
Okay, whatever operations we are performing on the
That
sets,
you can directly write.
it's
You can
always
directly write.
it's always having a common property, right?
See, if what I am thinking right now, you actually didn't watch that very first lecture. If you have watched that lecture, I don't think so. This doubt has to become
Oh,
because
no,
there I have already mentioned why we are using this set, why we are saying this is a set, and why we are writing why this is true. Like this union property will be another set. Okay,
yeah, so that is
that's the thing.
very basic thing.
Yeah, that's
That
the
and
thing. Huh?
I already watched.
Okay, Shall we move further?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, Cartesian product. Okay, Cartesian product is just a definition. You will write Cartesian product like that. Okay, Cartesian product. Can you take doubts in the end form now revision? I can take doubt for end, but the thing is, if someone has doubt in that certain topic, I don't think so. That doubt will be depends. Like it's very difficult for them as well, and for me as well. Again, going like I went going with the last topic and then explaining all those things. Okay. So what is Cartesian product actually? If you have a set A and set B, then Cartesian
Possible
product is
pairs.
defined at like that. Yes.
Possible pairs.
Yes, exactly.
Ordered pairs.
Such that A is coming from A and B is coming from B. Okay, this is the definition of Cartesian product. Then the further thing is relation. Relation is nothing but relation R is just a subset of A cross B. Okay, just a subset of A cross B. After that, binary relation is coming to the picture. Binary relation is what? If this B is equals to, if your R is a subset of A cross A, then we will say, yeah, this relation is a binary relation. Simple?
Yeah.
Here someone
Can you repeat
may
the
most
binary
probably,
relation?
sorry?
Repeat the binary relation.
Binary relation is not. See, here you are taking Cartesian product from A cross B. Now you can take Cartesian product from A cross A itself. Right?
Okay.
So whenever you will take a subset of this A cross A, that specified relation is known as binary relation. It's just like set of squares is also like there are some rectangles. Okay. These are the rectangles. But there are some square which are all like squares is also rectangle, right?
Yes, sir.
So if I will take rectangle, what's the thing? I can take easily. I can, if I will consider square as a rectangle, I can. Similarly, here A is non-empty, B is non-empty, but there is a possibility that sometimes B is equal to A.
Yes, sir.
Yes, sir.
Right? So for that, if B is equals to A, we will take, yeah, this relation is known as binary relation. I need this kind of relation. That is why I give an extra name binary relation, because this working on the set itself. Okay.
Yes, sir.
Okay. So there are some specific type of binary relation name as what? What is important for you? Reflexive. So first relation is coming to the picture, identity relation. So what is identity relation? Okay. What is identity relation basically? This is not identity.
Every codomain have a unique preimage.
Sorry. R is said to be identity element. Sorry, not identity element. R is said to be identity relation if and only if
Sir,
R
what
is
is
equals
my
to like that.
identity?
Identity relation is there, right?
Yeah, sir. Yeah,
Identity
identity
relation is there.
relation is there. Yeah, you have already covered.
Reflexive, symmetric, and
Sir, it's not included
did
in the
not.
book, but itself included in the definition of reflexive.
We have reflexive, symmetry, and transitive and anti-symmetric
Okay.
relations.
But identity is also important. Please just let me write it down. Okay. So identity relation is considering this all the element only. For example, if I have your set like this 1, 2, 3, then what is my identity relation denoted as like I is just a pair of 1, 1, 2, 2, and 3, 3.
Yeah.
Okay.
So
Just that's it.
reflexive.
And for a Cartesian product, identity relation is unique.
So, but same, it is also reflexive, no?
No, reflexive. This is a reflexive as well, but all a reflexive. This can be also reflexive. 1 1, 2 2, 3 3, then 3 1. This can be also reflexive. Okay. But this is not identity relation, because in the identity relation, I am allowing only this kind of pairs.
So the identity relation is a subset of reflexive, basically.
Yeah, identity relation is a subset of reflexive relation. So what is reflexive relation itself? What is reflexive relation? A relation R is said to be reflexive if this for all X belongs to R, or for all A belongs to this set A, your A kind of thing has to be inside A. Okay, for all A belongs to A, this pair has to be inside A. Apart from this pair, there is a possibility that there will be some element kind of that kind of thing. Okay. But I need to worried about this pair only. If the, for every element in A, this pair is inside A, then I will say, yeah, that relation will be this is inside R. So this relation will be reflexive. Getting my point? If for every element inside A, this A kind of pair is inside R, we will say, yeah, this is reflexive relation. Apart from that, whatever things are coming inside R doesn't matter.
Okay, sir.
Sir, you mean to say that it has to be defined on all the elements of A?
Yes.
Okay.
I have to check for all the elements of A. Okay. Now, what else? Symmetric relation. Symmetric, it's what? If your A is like AB, this pair is inside R.
The B also
then
in B also.
This implies
B,
A
A
has
also
to be
belong to
inside
R.
R. This is easy. No issue, right? Similarly, anti-symmetric is there.
So can you please repeat symmetric once again?
Symmetric is just saying if AB pair is inside R, then BA pair has to be inside R. And this is the important part. Okay, whatever I am discussing now after relation part, this is very, very important.
Sir, in
There
this
is a
symmetric,
possibility that at least one question will come from here.
sir.
Yes.
Hello, sir. If AB is there, BA is there. If BC is there, it is symmetric.
See, I am not saying about BC and whatever thing. What is my condition is? My condition is if something like AB inside R, if something is inside R, then I will go for BA and then I will see this BA is inside R or not. If this is inside R, then we will say it's a symmetric. Okay. Now suppose there is suppose 1 2 is not inside R. I am not going to discuss about 2 1. Okay, I will not going to check this one as well. You are getting my point?
Sir, in the PDF, sir, in the PDF, first
Yes.
relations are 1, 2, 2, 1, 3, 4, 4, 3. 2, 2 is also symmetric relation. They stated like that.
Yeah, 2, 2 is symmetric relation. Now, if 2, 2 is inside R, then what are this? This is your A, this is your B.
Again,
what
B,
you need to check?
A
BA
also.
inside
Okay.
R or
Okay,
not.
sir.
So BA is
Okay.
what? 2, 2 is only, no? Getting
Yes,
my
Okay,
point?
sir. Okay, fine, sir. Fine, sir.
So I have a
Fine, no?
question. In case like there are two sets A and B, right? And we set a relation of A to B, and then we get
Yes.
a Cartesian product of relations, like like a relation set. So for reflexive, are we going to check the elements only in A with respect to the relation,
The
or
thing is, what are the relation I am discussing from the identity relation? This all the part of this binary relation only. So here we are not including this B, extra B. Okay. We are discussing about this A only. Then only I can equate this element. Now I will say A type of element. If I have a different B, how can I make this A element? Because A, there is a possibility that A is not inside B. Getting my point?
Yes, sir.
Whatever relation I am discussing after the binary relation, these all the relation are part of binary relation only, special type of binary relation. Okay.
Yes, I got it. So there was a question in mock where they tried to set up this relation, but they get
Can you take that the screenshot of the question and then paste in the group so that I can not group in the chat box, I will directly take the question.
Yes, sir, I have pasted it.
You have pasted already.
It's sending. Yeah, it's sent now.
Where? I'm not able to see. Very first.
It's sending.
You are sending.
Are you able to see now?
Yeah, it's good. So what is the doubt here?
So they are setting up the relation in between A and B, where A is a subset of B. So here, are we going to define
So
two
where is
sets?
that question?
Everyone is able to see the question. So what is the doubt? Can you repeat it again?
Yeah, so
Yes,
they're
sir. Able
setting
to
up
see.
a relation in between A and B. So they are doing it with two sets here, right?
Yeah, they are defining what they have considered. They have considered set of set. Okay, so they are considering a relation like that. A itself here, this A is a set, but this A is a behaving like a what? Element. Forget about it. Don't treat A and B as a set and then try to see. Basically,
So
what
can
kind
you
of
solve
relation it
this
is?
and tell us?
Yeah, I'm telling. Suppose you have a set S. Okay. This is your set. 1, 2, 3. Okay. Define your power set S. What it will be? 5. Then singleton 1, singleton 2, singleton 3. Then 1, 2, 1, 3. Then 2, 3. And then at last 1, 2, 3.
1, 2, 3.
Right? Right? This is your power set. Now define a relation R. Can I give another name of this power set S? Say capital A.
Yes, sir.
For my for doing all the
2
things.
and 3. 3 will also be there.
Why?
Sir, we are making power set of 1, 2, 3. So all the elements possible elements will be taken now. 1, 2, 3, 1, 2, 1, 1, 2, 3. 1, 1.
You are writing this. You are saying this.
1, 1 is already there. I'm saying will 2, 2 and 3,
Is this
3
a
will not be
set?
taken.
Is this a set? Is this a set? My first question. Because for being a subset, firstly, it has to be set, no? Is this a set?
It's a relation.
Because in the set,
identity
repeating part we are not including.
Yes, sir.
In the set, we are not saying like there will be common. This is not a set. 1, 1, 1, 1,
Okay,
1. This
okay.
is not the set.
Okay, sir. Got it. Okay.
Okay, so we are defining a relation R A cross A, or let us say, don't make so much confusing notation. PS. Okay, this is my relation which is defining on PS cross PS. Okay, so this R is what? Subset of this, right? Right. If R is a relation, it is a subset of Cartesian product of power set, right?
Yeah.
Yes, sir.
Up to this, everything is clear. I had a set. I define a power set of S, and then I am defining a relation on the power set of S itself.
Yes, sir.
Okay, so basically this relation is R is what? Subset of this power set S. Just see the element of power set. This each element are sets itself, right? Sets
Yes,
of what? Subsets of what? S, no? So they are sets itself.
Yes.
But here we are treating like what?
Elements.
Element, no?
Element.
These are all the element of power set, and also subset of what? S. So they are sets itself. So I am defining this relation on power set. How will I define? I will say this is a pair of A and B or what? A and B are element of this
Power
power
set.
set of S, such that A is a subset of B, where A and B both are element of this power set S. Got my point?
sir.
Yeah.
Now you can do.
Sir, in the power set, 1, 3 is missing.
Here. This is 1, 3. Okay. Okay.
Yeah, actually that was confusion, sir.
Okay, yes.
Now it's fine. Now
Yes.
you understood the relation now?
Yes, sir.
See the question.
Basically, relation can only be defined on the same set itself. You cannot include two sets.
Now what? Binary relation.
No. Only binary
We are talking
relation,
about
not
binary
same
relation.
set.
Okay. That is why we have given a different name now. Otherwise, my work will be done by relation only, with that name only. Why I introduced the different name? There will be some reason. That is why I am introducing another name now.
Yeah, like the question got solved, but I had that like very slight doubt in there. Yeah.
Now it's clear?
Yes, sir. Yes, clear.
Okay. Okay, then what is next?
Could you please solve that?
The question is solved, no? This relation, what are the relation you understood now?
Sir, in the
These are the
PDF.
relation.
Sir, in the
Now,
PDF. Sir, in the
Sir, how
PDF
it is
R3.
reflexive?
R3, sir, reflexive. In the PDF.
PDF, this one.
In the
R3,
PDF,
this one.
R3. Yes, sir. 1, 1, 2, 4, 2, 4 and 4, 1.
This one.
Yes, sir. 2,
I cannot touch here. This
2,
one is what?
4. This is a
So
reflexive R3.
Okay. What is your set S? 1, 2, 3, 4,
1,
right?
2, 3, 4. Yes, sir.
Right?
1, 1, 2,
This is
2, 3, 3, 4, 4 are reflexive.
has to be there for each element. For one has, if R3 is reflexive for each one has to be inside that.
Yes, sir. 2,
For
4
two,
and 4, 1, sir. Only one doubt, sir. 2, 4 and 4, 1.
Doesn't matter they are inside or not. I am worried about this one is there or not. This 2 is there or not. 3 3 there is not. And 4 is there or not. After that, apart from that, whatever things are there, whatever things are not there, I am not going to bother about it.
Okay, sir. Okay.
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 Sir.
But in the identity relation, I will stop up to this. If something extra inside this will not going to be identity relation. Like R2 and R3 are not identity relation, but R1 is the identity
R1
relation.
is an identity relation. Okay, sir.
Exactly.
Sir, in symmetric relation, R3 is not symmetric.
This one.
Yeah.
Yeah,
R3.
because for 3, 4 here we are seeing in the R3 itself. For 3, 4, 3 is not there.
Yeah.
Okay, we are not going to bother about, sir, what about this 1, 3? Sir, do I have to check 1, 3? See, 1, 3 is not inside R3. Why we will check for 3, 1 and 1, 3? No, no. We will see the element of R3 itself. Okay. 2, 1 is there. I need to check. Yeah, for 2, 1, 1, 2 is there or not. Here, 1, 2 is there. Now, move to the second element. 1, 2 is there. For 1, 2, 2, 1 is there or not? Yes, 2, 1 is there. Now, move to the third element. For 3, 4. 3, 4, 3, 4. 4, 3 is there or not? See, 4, 3 is not there. My job is done. R3 is not symmetric relation.
Okay.
Sir, can we say all identity?
Each and every element.
Yeah, we have to check by one by one for each and every element.
Okay, sir.
But R3 is not transitive, right?
We did not discuss transitive here right now.
No, but just
I will explain and then we will say. Okay, now transitive relation. Transitive relation is what? As you can see, for each x and y, x, y, y, z has to be inside this. Okay, just give me some time. If I will able to write here itself, then it's fine now. Just give me, because it will reduce my time. I am not able to write. Okay, print. I can print here.
I think you can download this and then open it with OneNote, and then you can write in there.
Okay, now it's fine, I guess. Yes, now I can write. Yes. Or one more thing that I can do. Just a minute, okay? Sorry for interruption, but I think this is important. Okay, I think this is not working fine for that. So I have to use.
Sir, I think you can just open the PDF with OneNote directly, and then you can edit
No,
it.
I cannot open the PDF by OneNote. Okay, that's the thing. This is not the like PDF. This is something else, some another file, I guess. Only one slide is downloaded.
So for slides,
Okay.
there is an export option. If you can
If
download it.
there is no export option. Okay, doesn't matter. Let me buy this way. Otherwise, it will take some time. Leave it. Okay, let's leave it. Okay, transitive relation. We have to use OneNote. Are you guys ready for this session up to 12:30?
Okay, sir.
Yes, sir. Yeah.
Yes, sir.
Because last
Sir,
time what
yes,
happened
sir.
that like for the qualifier, like for not qualifier for end term, in the end term, like that session was going from 8 to 12:30. Like in that session, I have covered the week 1 to week 4, whole thing.
Yes, sir. Today you can take all the week 4 questions.
No, it's very difficult. Okay, it's very difficult because the thing is that session was for end term. But in the end term, like everyone is aware about week 1 to 4. They don't have the like small doubts. Okay, but here most of the people haven't watched the videos and they are directly coming. So that's the thing. They have some small doubts. That is why the session will be longer. We need some times. Okay.
Sir, can you take one more sessions of week 3 and 4?
It's very week 3 and 4 will be taken by
After
like
this,
Vishal
like
sir.
tomorrow and the next.
Tomorrow is Friday, right?
Huh?
Yes, sir.
So
Yeah.
tomorrow there will be one session for Vishal sir for week 3 and 4. Okay.
Okay.
Okay, sir.
So
That
you
section
can
is in
join that.
morning 7 o'clock.
Yeah, morning
But if
7 o'clock.
you have extra time, then
Actually, as I don't know, I have told you or not. Actually, we have annual event for our mathematics department, IIT Madras, name as 4S, which is on Saturday and Sunday. So I am not available for these days. That's the big
okay,
issue
sir.
that
No
I am
problem.
facing right now because I am in the team and I have to worry about up to 500 people and 400 people around. So that's the big thing.
Okay.
And handling for school kids, you can imagine the thing is handling a school kid up
Okay,
to
sir.
400. It's a very big task, na? So we have to plan each and everything. So I have to be there for that. So that's the big issue. Otherwise, I may it may be possibility that there will be possibility for end term. I will take all the revision session. But for qualifying, it's very difficult, right? Because I don't have much time. Like yesterday, I have taken for math 2. Now I am taking for math 1. Yeah, if I have, I will just tell them, but it's very difficult for me to take the session because I don't have much time.
Sir, if you have only 1 hour, then you can take in that 1 hour you can take
So
the
they have already posted the revision
important
for every week.
questions of week 3 and 4.
Week 3 and 4. See, whoever going to take the session, I will let them know. Please mention those things as well. Because week 3 and 4 session is already happening tomorrow, no? Vishal sir is
Yes.
already taking that,
Yeah,
that session.
it is already
So why
scheduled
you,
at 7 a.m.
Yeah, it's already scheduled at 7 a.m. You can, if you are not able to wake up early in the morning, you can watch after the class as well. So it doesn't matter. But like repeating this thing again and again, it's a really big task, right? You can understand, I guess, what I am trying to say. But yeah, still,
Okay,
if I
sir.
will be
Okay.
free, then I will compile for all week 1 to 4 in one session. But it's really kind of impossible thing because I have so many things to do right now. Right now, I
Sir,
am too busy.
please
That's the thing.
send me
Okay,
that
sir.
link where you told.
Yeah, because only 3 or 4 sessions are there for revision session. Okay, if you want to watch, you can watch. I am talking about my revision session. Okay, my revision session only 3 to 4. And if you will
Where can I find
calculate,
that?
On YouTube channel, sir?
yeah, YouTube itself you can find, or you can find a calendar. Like usually Sunday classes.
Sir,
Okay.
date. The date.
Date. How can I remember
You
the dates?
can
just
go
on
to the
YouTube
YouTube
and
channel
search
and
proceed, sir.
revision.
Please check the chat box. I have posted 3 links for the week.
Yeah. Someone has posted all the links. No.
Sir, please
Yeah.
proceed, sir. There are 3 sessions. I posted the 3 links. The second session
Yeah, I think
was
I
taken by
right
sir.
till now I have taken 4 sessions. This is my 5th session. Okay, quadratic equation I have covered. Quadratic equation. See, week 2 I have I have taken the general doubts. Week 2 I did not went to the concept because week 2 has just formula. That is why I am expending more time in the week 1 because here concepts are there. But in week 2 there will be some like only formula kind of thing. So week 2 is slightly easier than week 1. So that is why I am expending more time here. Week 2 we can directly go. So that's the thing. Okay, sum squared thing will be quadratic part, right? In quadratic part sum squared error will be there, right? Or in week 2 also. Yeah, week 2. In week 2 itself. Sum squared error is really important. You have to aware about it. Okay, so if you really want to see what is sum squared error, I have explained this sum squared part in week 2 solve with us session. In the very first beginning of the class, I have completing all those things in the beginning of the class. The session length around 1 hour 40 minutes because the session was interrupted because of some reason. The session was closed. If someone has remember the thing.
yes, sir. I was there.
Yeah. So yeah, you can watch the solve with us session for week 2. So here I have I have covered the sum square thing in a very deep way. Okay, why we are doing this kind of thing. You can watch in 2x speed. And if you are able to understand the topic, you can skip the part as well. Okay. So you my suggestion is just go and watch. I think you can understand what are the thing because the speed was very low. Someone was complaining, sir, you are going too slow. So that's what I'm saying. You will easily understand what was there exactly. Okay.
Sir, what is the answer for this one? It is transitive, right? This previous question.
Which one? This is transitive. This one, no?
Yeah, the relation one. A subset of B.
Yeah, this is transitive or not? See, if A is a subset of B, B is a subset of C, then what? A is a subset of C itself, no?
Yeah.
Simple. This is transitive, reflexive itself because A is a subset of A itself. What about symmetricity? If A is a subset of B, does this implies B is a subset of A? No, right?
No. Only both
So
are
this
equal.
is not symmetric, not symmetric. Okay, let's move to the transitive relation. Okay, what is transitive? Simple. If A is inside R, AB is inside R, BC is inside R, then this implies that A and C both are inside R. Okay. If this thing happen, then only I will see this. Okay. If one of the thing is not happen, we will not going to bother about it. Okay.
Okay,
sir.
So if one of the thing not available, then AB will be a transitive, correct?
Yes. Okay, someone is asking in which video sir explained all the weeks. Okay, if you really want to see that video, Narendra, you just go for term September 2023. There are last 3 video. Okay, so the like the third one, the last one was week 7 and 8. The second last one was okay. Third last one. You can see the third last one. There week 1 to 4. All the thing compiled in one video. If you really want to ask, week 1 to 4 are there in that video. The video length is around 3 hour 30 minutes or 4 hour, nearly 4 hours. All the things are covered from week 1 to 4. If someone really want to watch my video, you can go for September thing. Okay.
Okay.
There are playlists in the IIT MBS program itself. Okay, let's see the example in the slide, whatever we have. Where is the slide? Okay. So that's see this R1. Does this R1 is transitive?
No, sir.
Please mute. Anjali. Okay. This is not. Why this is not transitive?
This is transitive.
Yes, sir.
Sir, this is transitive.
Sir,
This is transitive, right?
3 and
Because
1 3 is
yes,
1
sir.
2
there.
is there,
It is transitive.
2 3 is there, 1 3 is there. So this is transitive. Similarly, what about R2? This is transitive or
Yes,
not?
sir.
Yes,
Yeah,
yes.
it's
This is
also.
transitive because 1
Sir,
4
can
is
I
only
ask
there.
something? Why there is R1,
Yes.
R2, R3, 5 till 5, sir?
Sorry, 5.
No, sir. Why there is R1, R2, R3, R4, R5?
These are the example.
Oh,
This
R1,
one is
okay.
R2 are
transitive
just
relation.
yeah, just
Example.
notations.
This R1 is another relation, R2 is another relation, R3 is another
That
relation,
all are the
R4 is another.
correct. All are the correct relations.
Yeah.
And we have to check that. We are that's why we are checking now. Just like
Okay,
symmetric relation, this is not symmetric relation. So I cannot say all the correct example of symmetric relation or not. Because
Yes, sir.
3 4
That's
3
what
4
we are
4 3 is
checking.
not there. Okay, that's what we are checking. Okay, so R2 is a transitive relation, right? You
Yes.
can see here example is it's a transitive relation. What about R3?
No, sir.
No.
Why it's not transitive?
Yes.
Because
Just pick a 1 3 part. Whether like in the first place 3 is there anywhere. It's just like for 1 2 in the first place 2 is there.
Sir, it
Okay.
is not
Sir,
symmetric.
1 3. If there is 3 1, 1 4, 4 1, then R3 is transitive.
R3 is also transitive, right?
Transitive.
It's
Yes,
transitive.
sir.
I am seeing 1 3 here. I am not saying any kind of this kind of relation, right? 1 3 is there, and what are the what is the another one?
1 comma
1
4.
4.
1 comma 4 is there. Okay, just pick this one as AB. So AB is your 1 3. What about this BC? Is there any element BC kind of thing here, like 3 relating with some other element?
No, sir.
No, right? So
No.
why we will discuss about this? If this thing is like fail from here itself, we are not going to discuss about this because we are checking the R element of R itself. Now we are not bothering about any other element. We are checking just element of R itself. So I pick 1 3 and I am checking is there any element 3C kind of R there inside R or not. If not, then we will leave 1 3. Okay. Now let's move to the another element 1 4. Okay, 1 4 is there. Yes, sir. 1 4 is there. Is there any element R in R 4C type of? Any element are there or not?
No, sir.
No, right? No, right? So I am not going to bother about this. It means that I am not getting any such element like this. So I will not check this. It's still a symmetric transitive relation. Got my point? Now there is a if there will be possibility that 1 3 is there and 3 2 is there. Now I got this 3C type of element. Okay. Then I will see whether 1 2 is inside R or not. Okay. But I don't have this kind of element. Why I will check? Because the first condition, the second part of the condition is not satisfying. Okay. It's just like if you will give me 10 rupees with 1 cup of tea, I will teach you what is anti-symmetric relation. Now, if you will give, if you have given me 10 rupees and you are not giving me coffee, why I will teach? Thus, I will discuss about this teaching kind of thing. Firstly, you have to fulfill my initial condition. Then only I will discuss about the further condition. You are getting my point?
Yes, sir.
Yes, sir.
So result is it is transitive relation.
Yeah. Firstly, whatever things are there, you have to that has to be satisfy the initial condition. This one. Okay. If this condition is satisfying, then only I will discuss about this AC part. You're getting my point? If one of the condition is discord from these two conditions, I will leave them. I will not going to discuss that element. I will leave for the another element. Okay.
Yes. Okay. So it is like a false statement can imply any statement.
Yes.
Is it?
Exactly.
Okay, sir.
So this is also a you understood. Someone was having some doubt in it. You understood why it's a transitive relation? Because for 1 3
yes,
there
sir.
is no element for
3 1.
3C.
Okay.
3 not 3 1 3C. C can be anything 1 2 3
3C.
4
Okay.
anything.
Okay, sir.
Okay. What about the R4? 2 4. Let's take a 2 4. Okay. Is there any element for 4? Okay. Here for 2 4 4 1 is there. Now initial condition is satisfied. For 2 4 4 1 is there, 2 4 is there, 4 1 is there. Now let's talk about 2 1. 2 1 is there or not? Yes, it's there. Now it's there. Completed. Let's move to the another one. For 1 2, is there any element 2?
2 1.
2 1 is there.
2 1
Yeah.
is there.
2 1 is there and also
It
2
is
4 is
transitive.
there.
1 1 is there. Yeah, it is transitive.
2 1 is there. 2 1 is there. 2 1 is there and 2 4 is there. So let's talk about 2 1. If I will take 2 1,
No.
I need 1 1 is inside. Yes, it is there. Now let's
Yeah.
take this 2 4. So I need 1 4. Yes, 1 4 is there.
Not transitive.
Yeah.
Not transitive.
It's a transitive, na?
No, for 2 1 there is no 2 2.
2 1.
2 1, I need 1 1.
Yeah, sir. We need 1
No.
1.
For 2 1, if you have to
For
start
1
from
2
starting,
and 2 1.
the second
For
element.
1,
The second
I
element.
have taken this second.
Yeah. So
first
it would
element.
be 2 2, right? Not 1 1.
I have completed up to this. Then I will move from this, and this. Okay.
Yeah,
If I
yeah.
will take this, then I will see for 2 1. Yes, there is 1 2. Now I will check for 2 2 is there or not.
No, not there, right? That's what I'm saying.
Okay, not there. So not understood. The thing is, I am checking one by one. That is why up to this I am saying, yeah, this condition is
Okay.
fine. Now
Okay.
I'll move to the 1 4. Then I will see, yeah, for 1 4, yes, 4 1 is looking like yeah, it's there. Now we will discuss, yeah, whether 1 1 is there or not. Yes, 1 1 is there. Let's move to the 4 1. Okay, so 1 2 is there for 4 1, 1 2 is there, 1 4 is there, 1 1 is there. Okay, so let's take one by one. For 4 1 and 1 2, whether 4 1 and 1 2, 1 is this, 4 2 is there or not? No, my job is done. This is not transitive because 4 2 is not there.
Okay.
Okay, so this kind of thing you need to check. Now, what about R5?
It is transitive.
You can check. You can check. Okay.
Yeah, it is.
Not transitive.
Okay, then equivalence relation. Equivalence relation is what? If a relation is reflexive transitive, and symmetric, then that relation is known as equivalence relation. Okay. If a relation is reflexive, symmetric, and transitive, then we will say that relation is equivalence relation. If R is reflexive, symmetric, and transitive, then R is said to be equivalence relation. Simple.
Yes, sir.
Anti-symmetric. Anti-symmetric is nothing but simple is that what
Sir, can you please repeat once again? Equivalent.
equivalence relation. If R is reflexive, symmetric, and transitive, then we will say R is equivalence relation. Okay, simple.
Sir, could you show me the transitive, the R4 relation?
R2 relation. This one.
R4, sir.
Here is R4. This one. Transitive.
Yes.
This is not transitive,
Yes.
no.
That is not
But
transitive. Okay. But
not
it is
transitive.
given as okay. In the PDF only.
This
R4
all there are some examples which are not transitive as well. Okay.
Yes, in the PDF, they have given only R5 is not transitive. That's why. Okay.
It doesn't matter. You need to check one by one. No? You cannot blindly believe on that. Because
yes. Thank you.
We can commit
Excuse me,
mistake.
sir.
Yes, yes.
Sir, if
Yes,
it
Palak.
if there 4-2 is available, sir.
Yes, yes, yes. If 4-2 is
So if
available,
4-2 is there, sir, then it is a transitive.
no, then we will check for this 1-1. Then after that, if this 1-1, we will check if all the conditions are satisfying or not. Satisfying, then we will move to 2-1. Now, once we will move to 2-1, now 2-1 is there, 1-2 is there. If you are able to see, 2-1 is there, 1-2 is there. But for these two, 2-2 is not there. So not transitive. Now, if 2-2 is also there, then we will say it's a transitive relation.
No, sir, 4-4 is also should be there also, no? 4-4.
4-1 and 4.
Sir,
Yeah,
here
4-4 has
4-1.
to be there.
Yeah.
If
Okay, so
anyone
fine.
we cannot find, then it is not transitive.
Exactly. We will check one by one. I will take 2-4. Then for 2-4, I will check all the conditions. For 1-2, I will check all the conditions. Then for 1-4, I will take all the conditions. See, though you can think like, sir, it's a very hectic time. It will take too much of my time. Don't worry. In the examination hall, it won't be take too much of your time because the question will be like that. Okay.
Yes, sir.
Sir, related to the same, I have posted one question on the chat box. Can you explain that?
Where? I am not able to see.
Sir, can we say all
Asif, right?
identity relations?
Yes, sir.
Sir?
Which relation? Yeah, the question is not visible. R1 is a function. Where is R1, R2, and R4? R3. I think this is a PYQ, na?
Yes, sir, it's PYQ.
It's a PYQ. Okay. Shall I take this question in the last of the class because it takes some time?
Yes, sir.
Yes, sir. It will be better.
Sir, am I audible?
Yes.
Sir, can we say all identity relations are reflexive also?
Sorry?
I'm saying, can we say that all identity relations are reflexive also?
Yes, you can say by the definition of identity relation. Okay, so my suggestion is, guys, for you, see, remember my this kind of thing. See, what are the revision session are there? Please go and like try to attend the session in the live session itself because it will be really helpful for you. Just like you are you having some doubts in that portion. That if you are attending the same session like the revision session in the beginning, like we start in the starting of the weeks, okay, starting of the terms, so that doubt will come on that time as well. So if you will ask there, I have your another instructor have too much of time because in one session we have to discuss like in two sessions we have to discuss for 1 week only. Here in one session we have to discuss for 2 weeks. But in the starting of the class we have 2 sessions for discussing 1 week. So we have lots of time there. Okay, so there you can ask for each and every small doubts. What's my point? So for the next upcoming week, I am saying, please try to attend all those sessions and then ask there itself. If the doubts are clear in that session itself, this session will be going to smooth, and I don't think so that like the session, like the burden will be high in your head. You will be easily to understand, easy to like you won't face any such issue. Okay. Okay. Shall I move forward further?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what is antisymmetric relation? A relation R on a set A called antisymmetric if no. Okay, basically this is confusing. What is antisymmetric basically? So antisymmetric is saying if AB is inside R and A not equal to B. Okay, AB is inside R and A and B both are not equal to each other. Then we will say BA is not inside R. Simple. Okay. If just like this, if 1, 2 inside R, just see whether 1 or 2 both are equal or not. Here 1 is not equal to 2. Then we will say yeah. Then we will say 2, 1 is not has to be 2, 1 is not allowed to be an element of R. Got my point?
So then if it's element of the both, then
now if this kind, if 1, 2 and 2, 1 also there, then we will say this is not antisymmetric relation. Okay.
So if a function is not symmetric, does it mean that it is antisymmetric?
No.
Antisymmetric
if a
is
sum is
opposite to symmetric, sir. Right?
Sorry. Not opposite to symmetric. See. This is symmetric relation.
Yes.
Yes, sir.
This is antisymmetric as well. Okay. Because if I will say 1, 1 is inside R, then here this quality will not true, right? Not equal to property. Right? So the second condition is discord. It means that I am not going to check this one. You're getting my point?
Yes, sir.
Now this will allow to be an antisymmetric. So this is antisymmetric as well, symmetric as well. So you cannot say it's the opposite thing. Okay. Okay.
Okay, sir.
So whatever thing discuss up to this, the relation part and then the cardinality part, it's very, very important. Okay. Mark those things. The relation.
So then all reflexives are antisymmetric.
Non-reflexive.
Then all reflexive relations are antisymmetric.
All reflexive relation are no, we cannot say like that.
But reflexive, what you told 2, 2 is a reflexive also, na?
Let's discuss about okay. Here I will add an element 4, 2 here. Suppose this 4, 1 is not here. Here 4, 2 is there. Okay. You are able to see the marker? Hello? Are you able to see the marker?
Yeah, tell.
If
Yes,
here
sir,
4, 2 is there, 4, 2 is there, still this R3 will be reflexive, right? Right?
Yes, sir.
Also.
Yes, sir. Yes, sir.
Right?
Yes, sir. Yes, sir.
But it's not antisymmetric because for 2, 4, 4, 2 is there. I am saying this one is the 2. Okay. For 2, 4, 4, 2 is there. But what I am saying, if 2, 4 is there and since 2 is not equal to 4, it means that it won't allow 4 to be inside this R. Okay.
So can you explain once again?
What I am saying actually. Suppose you have this 1, 1, 2, 2. Okay. My set has only 2 elements. Okay. For the simplicity, only 1, 2 are there. These are there. Okay. Let's take 3, 1 as well. 3, 3. Now, what I am saying, 1, 2 is 2, 1 is there and 1, 2 is also there. This is not symmetric, right? sorry, this is symmetric, right? This is symmetric relation. Reflexive as well, because for all 1, 2, 3, there are 1, 1, 2, 2, 3, 3 kind of element.
Yes,
Right?
correct. Yes.
Right? Now, what about this 2, 1? 2, 1 is there, and 2 is not equal to 1. But 1, 2 is inside this. But what I am saying, if this the first property is hold, so for anti-symmetricity, this BA is not inside R. 1, 2 has not to be inside R, but here it is inside. It means that this is not anti-symmetric.
Anti-symmetric.
But it's a reflexive relation, right?
Okay.
Yeah,
Okay,
yeah.
sir. Thank you.
So basically for anti-symmetric, if A comma B is in R, then B comma A should not be in R.
If both A and B are not equal.
Okay, makes
Right?
sense.
So could you repeat for the point if the set only has element 2, 2? Will it be symmetric?
Yeah, it's symmetric, no? Symmetric relation, what the symmetric relation say? If AB belongs to R, then BA has to be inside R. This is the symmetric relation.
Yes.
Now, in this case, A and B both are 2, 2. So for 2, 2 belongs to R, 2, 2 is also inside R. It means that, yeah, this is symmetric if this singleton set is also there.
Got it. Okay, so.
Simple.
Sir, if we have only identity elements, then also it is
Symmetric and anti-symmetric both.
Okay, thank you.
So all transitive relations are anti-symmetric?
No.
No.
Our identity element. Our identity element, no, identity relation.
Okay.
Okay. Transitivity is a different thing.
So please once again explain the anti-symmetric.
Anti-symmetric part. What I am saying in anti-symmetric. I am saying if AB belongs to R, if R is anti-symmetric and AB belongs to R, and A and B both are not equal, then BA is not allowed to be inside R. Got it?
Not if BA is there, it is not anti-symmetric, correct?
Yeah.
And
Yes.
it applies for all the elements, like all the.
Okay.
We will check the elements inside which are inside R only. We will not going to bother any other element.
Yeah.
Okay. We will check the inside R element only.
So in R, if there is like A, B, then B, C, then C, we're gonna check for A, B, then we're gonna check for B, C, then we're gonna check for.
Exactly.
And all of them should be anti-symmetric for the whole function to be anti-symmetric.
Yes. For whole relation, not function.
Okay.
Okay, let's move to the function definition. Okay.
Sir,
So my suggestion
question,
is,
sir, when A is the subset of B in that question, anti-symmetric, it is anti-symmetric, right?
A is a subset of B.
Yeah, the previous question that we discussed, in that it is anti-symmetric.
Yes. It is anti-symmetric.
Okay.
Okay. See, in the function part, I'm really suggesting you please go and watch the second revision session, because the function part I have discussed in a very deeply way. Okay. So I'm not going to discuss all those things. Just see the definition. What are the things are here. Okay.
So for the function, I only have one specific doubt. Like if we have if we are given a set, say x equals 1, 2, 3, and but we are also given a relation that has only pairing of 1 to something and 2 to something. 3 is not included. Means an element of this initial set is not included in the relation. So so by definition, because it's not defined for the complete domain, it should not be considered a function now. Just
Yes, exactly.
Okay.
Exactly. Because function is what? Let's discuss.
It should be defined for.
I don't know why I am following that slide. Okay, let's discuss what is function basically. Function is what? As I have earlier told you, function is just a magic box. Okay, it's a magic box which is taking some inputs and doing some kriya karam into it and giving me output. Okay. This is basically function. Really appreciate your dedication. Thank you. Bye, sir. Okay. Okay, it's okay. You can be there, Aditya. No issue. No issue. You can be there. If you have doubt, you can ask. Okay. I will take this session, like I will complete week 2, then only I will close the session. Don't worry. Okay, function is what basically? It's a magic box which takes some input and give me some output. Okay. Now there are some constraints, or according to that, we will say this function is nothing but a special type of relation. Type of relation. What kind of relation it will be? See, the first one is the relation, or whatever you are discussing. This the relation has to be satisfy one property. Like, what are the input you are taking from the set? This 1, 2, 3. Suppose here 4 elements are there. This from this set, and you are defining your function from S to some other place. Okay. So each element, this 1, 2, 3, and 4, has to be a unique element in the another set, say S prime. Okay. Each element, say 1 has to be an output, 2 has to be an output, 3 has to be an output, 4 has to be an output. Just like if you suppose you have a chips making machine, so if you will throw potato inside that, you will get some chips. Getting my point?
Yes, sir. Actually,
right? If you are giving some input, you have to receive the output. If you are not getting any output, it means that it is not a function. Because you are continuously throwing something inside that and you are getting nothing. Simple. So what are the conditions? For each x belongs to this S, there is an element y in S prime such that there is exactly one element y belongs to S prime such that whenever I will apply this function on this input value, I will get this y. Simple. Right? Easy enough. This is the condition. When I will say a relation is a function, if a relation is satisfying this property. What? For each element in S, okay, for each element in, see, here I am not talking about binary relation. Here I am talking about general relation. Okay. So don't consider this S and S prime both are equal. That they can be like other, like they can be distinct as well. Okay, I am talking about just relation, not binary relation. So what I am saying, function is a special type of relation. So someone will say, sir, what kind of relation it will be? So I am saying, yeah, if a relation is satisfying this property, what is this property? For each x belongs to S, if there is a exactly one y belongs to S prime, such that fx is equals to y. What does it mean? It means that f, which are relation which is operating on x. Okay. So this kind of relation is known as function. Okay. So if I am defining a function from a set to another set, then there will be something from where this function f can take inputs, right? It's just like if I am making this chips making machine. So is there anything from where I will throw the potato, right?
Yeah.
Or if you haven't seen this chips making machine, did you went to the atta shop, like you have did you take like did you seen that method where like in the TV itself, like you have seen that method now, where you will throw the beat into some container and then you will get some atta kind of thing.
Yes.
Right?
Atta
So
chakki.
what that machine will do, atta chakki, you can see. Everyone has seen that atta chakki, right?
Yes, sir.
Not seen.
Yes, sir. Yes, I've seen. I have seen.
Everyone has seen the switchboard.
Yes, sir.
Yes, sir.
Yes, sir. Switchboard everyone has seen, right? So what
Yes,
are the what thing you will do? Once you will on the switch on switch, your fan will give you the energy in the form of wind or in the form of whatever it is. Yes. Session is recorded. It is streaming on the YouTube. Okay. So what I am saying? No, I have only Alexa. Okay, it's okay. So what I am saying basically, I am saying whenever I am please mute Pawan. Pawan, please mute. Okay. So the thing is what I am trying to say. If you have seen that atta chakki, so what that atta chakki will do, it will take some wheat and give you some atta, right?
Yeah.
Right? Yes. So basically, it is taking some input from that container which is containing the wheat. Okay.
Okay.
And giving me atta as an output. Now I am saying, yeah, this is the atta chakki is made by like this. I am continuously giving weeds into it, but I am not getting anything. That thing will not happen, right, in the real life. Right? That's what I am saying. So function is what basically. So yeah, so there will be something from where that atta chakki will take the wheat, right? So that container will known as input set, or you will say that is domain for our function. Okay, domain for our function. So what is domain basically? Domain is nothing but domain is a set from where your function is taking value as an input.
Inputs.
Okay.
Input value.
Okay, so you can say domain of f is what? Domain is f, nothing but
codomain is an output.
Input values.
Input set. Okay. Now, simply, if you like you need something for collecting atta, right?
Yes, sir.
You need something for collecting for atta. So where you are collecting atta, there is a possibility that suppose you have a bag. In that bag, you are collecting atta, right? Collecting atta. So there is a possibility that bag contain some atta in the initial thing, like.
Sir, can I tell something?
Sorry.
Can I tell?
Yes.
Sir, input means domain and output means codomain. That's the function, no, sir.
Yeah, input set, not output set, and not output only. Okay, output you are saying like, sir, I switch on the board and then fan is imparted. I am getting output as an input. So what I am trying to say, I am saying output set, input set. Okay, just mention the set word there. Then we will say, yeah, it's domain. Not input. It means that you are talking about only one thing. But here you are talking about all over the input, set of all the inputs is known as domain. Okay. Now, what I am saying, if you have atta chakki, suppose this is your bag. So there is a possibility that without starting the chakki, there are some atta inside this bag. Right? There is a possibility, na? But still, I can use this bag as an containing all the outputs, right?
Yeah.
Okay.
Yes,
so
sir.
here the old thing is there, old thing, and I am taking output as a new thing. Okay. So this whole collection where I am containing the output is known as codomain. Okay, known as output set or codomain of F. Understood the point?
Yes, sir.
What is
Yes,
input
sir.
set?
Yes, sir.
And what is output set? Now, here I am adding some new things, right? I am getting some output or new thing. Old thing was there, but still I am getting some new thing.
Yeah.
Right? Right? So
Yes,
this
sir.
collection of this new thing is known as range of F.
Yes, sir.
Yes, sir.
Okay. It means that I am collecting all the output. Here I am discussing about output. I am not discussing about what are the thing inside already there. The old thing. I am not discussing about the old thing. I am only discussing about new thing. So the set of all the new thing or all the output is known as range of F. Got the point?
Yes, sir.
Okay,
Yes.
so this is the part of domain, codomain, and range. Okay, please, this finding the domain and range part is very important. So please go and work it out on the example, with the example, and then just go and see that try to attend that TA lectures where they are discussing some PYQs. So there they will solve the questions. Okay.
Yes, sir.
Okay. So for example, suppose you have fx is equals to this set x plus 1. Okay. Now I am just saying what is its domain or input set. So you need to check that for where this function will give me output, for which value of x this function will give me output, right? So you know that inside the root thing cannot be negative.
Yes, sir.
So you will say, sir, for this x plus 1 has to be greater than or equal to 0.
Yes, sir.
Or you will say, sir, x has to be greater than or equal to -1. So you will say, yes, sir. If you will take the value from -1 to infinity, this function will give me the output, right?
-1 can't be in.
-1 can be inside. Now, if you will take -1 here, this whole thing will be 0. Root 0 is 0 only. So you are giving some output. You are taking. You are receiving some output, right? What is my agenda? I need the collection of all the value for which I am getting output. So here for x equals to -1, I am getting output, right?
Yeah.
Got the idea?
Yes, sir.
Yes, sir.
Right? So the domain will be -1 to infinity. Similarly, suppose I have an example like this, x square minus 4. Now, 1 by x square minus 4. This is my function. Now, I need output from this function. So, I know for receiving the output from this function, the denominator part should not be equal to 0.
Yes, sir.
Right? It means that x minus 2, I can split it like that, not equal to 0. It means that x not equal to 2 or not equal to -2. Apart from that, I can take any value from r.
Yes, sir.
So r minus this 2 minus 2 will become my domain. You are getting my point? How I am finding the domain. So
Yeah,
basically
yes,
what I am trying to see, for what value of x I am able to receiving the output. Okay.
Yes,
sir,
sir.
there is any type of interval, sir, in domain?
There can be anything. Okay. There will be possibility that there will be some singleton set only. Okay. But domain always be non-empty. Okay. Phi will not become any domain. Okay. So got the idea now? How will you find a domain?
Yeah.
You have to see
Sir,
for
here
what
domain
value
of
of
R
x you
will
are
be
giving.
-2.
Sorry.
Sir, here domain of R will be -2 and 2, no?
Domain of f, na. Here,
Yeah,
where
yeah,
is the
yeah,
R?
yeah.
Domain
Yeah.
of f is what? R minus 2
R,
minus.
yeah,
We are
2
excluding
minus.
-2 and 2 from R. Okay. Got the idea for domain range? Because this is important, because that is why I am giving some time here. Now, after that, injective function is there. Injective function. So what is injective function basically? Injective function is nothing but, suppose this is your input set, this is your output set. Okay. So for each output, if you have a exact one input, it means that for here there is if something is defined. See, if you are making some chips, okay. Have you seen your mummy for making potato chips?
Yes, sir.
That is some glider kind of thing, right?
Yes, sir.
Here some press, and here there will be the potato. You will press that potato continuously. You will get some chips, right?
Yes, sir. Yes, sir.
Now there is a possibility that the size and shape of two chips will be same.
Yeah, yes, sir.
Yeah,
It means that what I am trying to say basically, I am trying to say there is a possibility that the two elements of input set can map only one element. from the output set? Or we will say, yeah, there is a possibility that two elements of the input set are giving me the same output. It's just like you have a switchboard. There is two switches, okay, from this fan. This is your fan, okay. My drawing skill is too bad. Please try to understood this is a fan. Okay, so what I am saying, for both these two switch, I can on the fan. Okay, if I will press this one, fan will on. If I will press this one, fan will on. It means that what? If I am giving you like two different output, but I am getting the same result.
Yes, sir.
Yes, sir.
Getting my point? There is a possibility. So, but in the injective function, that kind of possibility we will discard. It means that for each input value, I have a unique output, and that output will not be same for any other input value.
One and only unique output.
Yes, exactly. It means that if your x1 and x2 is coming from your domain set, and x1 is not equal to x2, then I will say the output will not be same. Okay. For two distinct element, if output is not same, we will say it's a 1-1 function for all x1, x2. Okay, I will pick any two different x1, x2, and I will tell whether this one is a 1-1 or not.
Yes, sir.
Right. Now, question is, how will I check, sir? How will I check? Suppose you have a function like this. Fx is equal to what? Suppose x plus 1 is there. This is your function. Now the question is asking, just try to just give me just tell me whether this function is 1-1 or not. Okay, how will I check? So I will say, sir, take x1 and x2 from domain. Okay, and they consider that both x1 and x2 are not equal. Please be focused in this class because this is very essential part. Okay, there is a possibility that the question will be come from this injective surjective thing only.
Yes, sir.
Okay, then I will make if this one is 1-1, then fx1 will not equal to fx2, right?
Yeah.
Now I am saying this is not 1-1, not 1-1, not 1-1. This is my assumption. Not 1-1. Then there is a possibility that for any x1 and x2, this fx1 is equal to fx2, right? At least one x1, x2 was there, na?
Yes, sir.
At least any one x1, x2 will be there. For that, this fx1 equal to fx2.
Tell something.
Yes.
Injective means for every input there must be an output differently. That's it, no, sir.
What injective means? Injective means simply if you have two distinct input, their respective output will be distinct.
Yeah, sir.
Right? Okay, understood? And then how will you check? So there is one way that I am saying. Okay, so I am saying this is not 1-1. I am using contradiction part. So I am saying, yeah, this is not 1-1. So for distinct x1 and x2, there is a possibility there will be some two distinct x1 and x2 for which fx1 is not equal to fx2, right? If not 1-1, then just apply the definition. What you will get, x1 plus 1 is equals to x2 plus 1. Now from here, what you will get, this 1 will cancel out. You will get x1 is equal to x2. But your initial assumption was x1 is not.
One is not equal to x2.
X2. It means that it is contradicting our assumption. It means that whatever I have assumed, this is not 1-1. This is incorrect.
Yeah.
Yes, sir.
Right? So it's a 1-1 function. Right?
Yeah, sir, right.
Right? Now, another way, if you have a graph like this or like this, sorry?
For injective, it must be 1-to-1.
Injective and 1-1 both are same. It's just like my name is Arpit and Harshvardhan as well. Okay? But my identity...
Both are same.
Both are same, na? It's
So
just
that
two
means,
different names.
sir, if
for
inputs are same,
yes.
then outputs must be same for
Yes,
being
exactly.
an injective.
That's the definition of function, na? For one input, you will only get one output. Okay.
Okay. Then when do we say it is not a function based on the?
If you will get a two output for one input.
Sir, then we can say every function is a injective.
Sorry, every function. No. In the injectivity, what I am saying? In the injectivity, I am saying for two distinct input, I will get distinct output.
Okay, sir. Okay.
Simply, 1, 2, 3 is there. This is your domain set, and this is your 1, 2, 3, 4. Okay. I think it will be clear. This is mapping 1. This is mapping also 1. This is mapping 2. This is a function. Why? Because for each element, I have exactly one value in B. For that, this I am giving. I can relate the value, or I am taking the output. I am receiving the output, right? I have the output. I am not saying I have exactly one, but I am not saying that one will be unique. That can be anything, no?
Yeah.
Yeah, sir. Every distinct
What I'm
value
saying,
of
F1,
fxy should be
F1 can be
distinct.
F1 and F2 can be equal. Doesn't matter.
Sir.
But I am saying for F1, it will be like that. I am not saying this thing. 1, 2, 3 is there, sir. 1 is mapping to 1. And 1 is itself mapping to 2. This will not going to allow in function. Okay, 1 will map exactly one element in B.
Yes, sir.
Yes, sir.
Okay, exactly one
Many to
element,
one is
not
not
two
allowed.
element or not zero element. Exactly one.
Yes.
Yeah.
Okay.
But sir, different inputs may map to a
May
single output.
map to the same element, just like this. Now, what is injectivity saying? Injectivity saying, yes, sir, what you will do in the injectivity case, here one element can map only one element like this. We will not going to allow this kind of thing. For distinct input, output should be distinct, not same in this like this example.
Yes, sir.
Just like if algebraically I will give you the example, fx is equals to x square. If you will see image of f minus 1, it will be 1. Image of 1, it will be 1. This is not injective. Okay.
Yes, sir. It could be as a
Got the
function.
point? It's a function, na? It's a function.
It's a function, but not a
Yeah,
one
it's a
function.
function.
Not a one function. Got the idea?
Yes, sir.
Okay. So what I am trying to say by this graph. Now here you will see, if you will draw a line, this is your input function. Right? And here you will receive output in this line. So what you will see, this is a graph. What you will see, if you will draw a line vertically, so you will see for each input, you are getting only one output, right?
Yeah, yes, sir.
So
Yes,
if this
sir.
thing is happen for each input, your graph is cutting by this line only one way. So you will say it's a one function. But suppose your function is
Yes,
like
sir.
that. What I will say. Okay. What I will say. So here, it's known as vertical line test. So this is a function, right?
Yes, sir.
This is a function basically. This is a function. Now, if the case is happening like this, it means that for each input, you are getting two distinct output. One input, you are getting two output, not function.
Yes, sir. It is a not.
Not
Yes,
function.
not function.
Okay. Now, if you have a function like this, draw a horizontal line. Now, draw a line parallel to the x-axis, and then see how much how this line cut our graph. If the line is cut the graph by more than 1 point, then we will say it's not an injective function, because for two distinct input, this is input now. Here you are getting input, here you are taking input. For distinct
Both
input,
are
you are getting to same output, because this number will be same.
Yes.
Okay. So this is not a one function. You can check by this way. This is known as a horizontal line test. Okay, this will cover in the week 5. Okay, but still I have just give you the idea. How will you check? Okay.
Yes.
So just okay. Now surjective function. Surjectivity is what? Surjectivity is nothing but if your output function, codomain
Codomain
is equal to the range, then we will say it's a surjective function. What does it mean? It means that if there is no such free element are there, every element have their pre-image, or every element of this set B codomain is the output of something in set A. Okay, so that set is known as surjectivity. Okay, so basically there is no certain way to check it's a surjective function or not. Okay, you have to use your common sense there only. Okay. So one way I can say like this is just a common thing. See, you can, if you are able to show this thing, this is more than enough to showing surjectivity. Okay. If you are not able to show this thing, then you can use this one as fx is equals to y. Try to find of y, like trying to find. Suppose you have a function x square plus 1 is equals to y. Try to find the value of y in terms of x. Here you can directly find.
Sir, can you please repeat for surjective?
Sorry. Try to find the value of x in terms of y.
Yes, sir.
Okay. So for that, what you need to do? You need to solve the system x square plus, solve the quadratic equation. What will be the solution? Plus minus under root y minus 1. Right? Right?
Yes, sir.
But you need to check that this is defined or not. Firstly, okay?
Yes, sir.
Okay, so you can check like this. So you have a function, try to find that function, the value of x in terms of y. Just equate it fx as equal to y and try to find x in terms of y. So if you are able to find that, then you will say, yeah, it's a surjective function. If you are not able to find, not surjective. Simple. Not able to find it, not able to find, you cannot say anything. Okay, there is a possibility that is surjective, but you are not able to find. But someone is there in this earth, they will be able to find. Okay. Okay.
So can you please give one more example of this?
X की power 77 plus x raised to the power 79 something x raised to the power 100 is equals to y. Find the value of x in terms of y. How will you find? This is your function now. No, right? Known as polynomial function that you have learned. Or you can say, sir, x raised to the power 77 plus x raised to the power 76 plus x raised to the power 75 up to 1 is equals to y. Now find the value of x in terms of y. You are not able to find the value of x in terms of y, right?
Yes, sir.
But someone will be here in this earth who will be able to find the value. But someone will there, right? So in that case, how will you check? See, if I will x goes to my x will go to infinity, this leading term will decide. This whole function will go to infinity, right? So this thing will be covered in the week 4. So let's do not discuss about it.
But sir, it is finite, right? Last
Sorry?
one is 1.
Yeah, up to finite thing. Now this is basically here
Okay.
x is there.
That is infinity. So what is that
If
last
this
term? I didn't understand.
if this x will take larger and larger, the input will go to larger and larger. The whole output will go to larger and larger, no?
Yeah, that's okay. So what is that last term? X plus 1 or is it infinity?
It's x plus 1. It's x plus 1. This is a polynomial basically. Okay. So understood the surjectivity concept or not? That was our main agenda.
Understand this? Yes.
Understood that? Let's move further.
Sir, here f of x can be same for both.
F of x can be
For any y, there can be two f of x.
Subjective.
For surjective.
Yes, there can be no. I just want to find one value. If I am getting more than one, it doesn't matter.
Okay. So f of x1 can be equal to f of x2, right? For surjective.
Yes. Yes. Bijective. Bijective relation is what? It's basically if a relation is injective plus surjective both, known as bijective relation. That's it. Okay.
Yes, sir.
Now, up to this, week 1 is completed, but I will mention some additional thing. Have you seen this increasing?
Still there is something there, no sir. Still there are many things, sir, to cover.
Like?
Or So for exam, if I learn this thing from week 1, it will be easy to clear exam, no sir.
Yeah, it will be sufficient to do the question in the quiz 1.
Yes, but you need to practice on the question. Okay, here I am explaining the concept, not the questions.
Okay.
So you have to be practice. It does not like you have just seen this lecture and you will be able to qualify the exam. No, the thing is not going like that. If you will like work
Will you
on the
elaborate on
assignment.
codomain and range, sir?
Did you watch the the previous thing? When I did,
Actually,
you
I
was
joined
there,
very
right?
late. I joined late at 10 o'clock. So
Okay, it doesn't matter. But yeah, the
okay,
thing
no
is, can
problem,
you
sir.
watch in the YouTube? Because
Okay, sir.
it's
Okay,
like
sir.
we
Okay,
have
sir.
one more week. That's the thing. It's really very hard. Like for one person wasting for other 31% time, I don't think so. It's a good idea.
That's okay, sir. Okay, sir.
Okay.
Yes,
Just
sir.
a
Move
word
to
I
the
am
week 2.
asking.
Okay. Okay, so I'm including one more thing, increasing and decreasing function. Have you heard about this? So basically for you, I am saying, see, what is domain? Domain is nothing but just input thing, input set. Okay, where the function is taking the value. Codomain is what? Output set.
Output
okay,
set.
Where the function is giving the value. Okay, range is what? Range is nothing but what are the output I am receiving. Collection of all the output. Simple. You can see the slide here.
Okay, thank you, sir.
Simple. In one word, domain is what? Input. Domain is what? Input set. Codomain is output set. Range is what? What are the output you are taking? Just take that collection.
That means range is the subset of codomain.
Yes, exactly. Okay, so increasing and decreasing. Have you heard this thing? Increasing and decreasing?
Sir, in stats,
sir.
we have that
Okay.
it's increasing or decreasing in the line,
Okay,
the
I'm
slope
writing a
thing, the slope
definition.
thing.
Okay. I'm writing a definition. See, this part is really important. Though it's not in your syllabus, but there are possibilities that they will ask some question, because in the polynomial thing, some questions are related to increasing, decreasing, I guess. Yeah, in the polynomial, like week 4. So they can ask
So
the
it's the slope.
question from it.
Like when slope is positive, then it's increasing. Slope is negative, then it's decreasing.
Yes. Its slope is positive for each point, but okay.
Sir, but
Okay, so let's see what is
decreasing.
increasing.
How it will apply in sets, sir?
I don't know. I don't have much idea about stats, so I cannot comment on that. So let's discuss about increasing. Increasing function is what? If x for x1 is greater than or equal to x2, if this thing is implies fx1 is greater than or equal to fx2. Then we will say this is for all x1, x2. We will say function is increasing. You are getting my point? What I am saying? Suppose I am arbitrarily taking 1 and 2. Now, here you will see 2 is greater than or equal to 1. If for that f2 is greater than or equal to 1, f1, then we will say this is a increasing function. Just like this, if you have a function like this, fx is equals to what? X plus 1. Just see. If you will see f2 here, what it will be? 3. And f1 is what? 2, right? Here you can see f2 is greater than or equal to f1. Right? Similarly, by this definition of function, you can able to see or not. You just see if you will take any value like this. Suppose you have taken 10 and then you have taken 11, or you can say, sir, I will take 1 in this case. F of 10 will be greater than or equal to f of 1 only, right?
Yes, sir.
For each case, whenever you will take the value like this, from a value like this, you will receive the relation like this, right?
Yes, sir.
So whenever this thing is happen, we will say it's a increasing function. So basically, if I will see in the graph of increasing function. So what I am saying, whenever I am going toward this direction, my functional value is going like this, right? Right? My functional value is also increasing.
Yes, sir.
So basically what I am saying, if I will took a value from here and here, so this is your x1, this is your x2. So in this case, you can see x2 is greater than or equal to x1, right?
Yes, sir.
Greater than x1. Yes.
Right? So your functional value is what? This length. This length is your functional value, right? Basically, here to here is your functional value. This length, the length of this line is your functional value, right?
Yes, sir.
Yes, sir.
So the length of this line is greater than the length of this line, right?
Yes, sir.
So your increasing function is look like this.
X2 is greater than or equal.
Right? Right? Similarly, if I will ask in this function, okay, this is your function. Minus 1, 0, 1, 2 is there. So if I will ask you, okay, if I will ask you, suppose this is your 1 by 2 and this is your 3 by 2. Okay, if I will ask you in what set this function is increasing. So in what set this function is increasing?
2 to infinity.
2 to infinity it's increasing, but I am discussing how in this set, whole the real line, in what set this function is increasing. So what you will
From
say, sir?
-1.
Here you can see
From -1
here
to
you will
half,
see
it's increasing. And from 3
Minus
by
1 to
2 to
infinity.
2, it's increasing.
right?
Yes.
Union 3 by 2 to
Infinity.
infinity, right? You are getting more
Yes, sir.
like see this is additional part, but increasing. Have you got the idea about increasing?
Yes, sir.
Yes, sir.
Now, if I will ask you the question in this set, the function is increasing or not?
No.
This function in
Yes,
this
sir, it
set,
is
the
increasing.
function is
Yes,
increasing
sir,
or
it is
not? Yes.
increasing.
Yes, sir.
You
Yes,
you
sir.
have
It
you
is
have to see
increasing,
that
sir.
this portion
Yes,
only,
sir, increasing.
right?
Yeah. Yeah.
Got the idea? What is increasing? Okay.
Yes, sir.
If I will ask you what is the maximum value of this function, what you will say?
Infinity. No.
This value. This value is looking
Yes,
like a
sir.
maximum, right?
Yes.
Yeah.
Yes, sir.
Right? Like at least in this region, in this local region.
Yes, sir.
What does it mean by local? Okay, you will confuse. So, motivate, I will say, see, each area has their MP, right? Member of Parliament.
Yes, sir.
Yes, sir.
Each certain area has their MP. Now in the parliament, each MP was there.
Yes, sir.
From some other reason, right? Other reason, they will represent the another reason.
Yes, sir.
Okay. But there will be some prime minister kind of thing, right?
Yes, sir.
Which is head of all of these MP.
Yes, sir.
Right? So this is head of all of these.
Sir, what topic is this?
This is just the maximum minimum.
Increasing
some
functions.
questions are there. Some questions maybe they will ask from there, because for polynomial part they can ask. So that is why I'm just introducing this then. So just I'm giving you the idea what is maximum value of function and minimum value of function. Simply. Okay. Okay.
Yes, sir.
Yes,
sir.
Go ahead, sir.
Okay. That is why I'm explaining all those things.
Sir, before maxima and minima, it was increasing, decreasing only.
I have explained that increasing part. Now, in this graph, I am saying what is maximum and what is locally maximum, local maximum kind of thing.
Okay, okay.
So that thing I am explaining. So what in this parliamentary, there is a prime minister, right? But this prime minister is come from one of the MP, right?
Yes, sir.
Similarly, but locally, this one is the head, right?
Yes, sir.
So similarly here, if I will talk about this local region, which value is like leading the entire function, which value is the maximum one?
Minus 1 by
This
2.
one.
Yes,
This
minus 1 by
one.
2.
At minus 1 by 2, you will get your maximum. So in this case, they will
Yeah.
say, yeah, this is our local maximum. Why it is called local maximum? You got? Though this
Because
local
in that
maximum,
region,
they
this is
will.
the maximum.
In that domain, it's the maximum.
Yes.
Yeah.
So though the thing
All
is, they will
curved
not
point
going
is
to
known
use
as
this
local maximum.
That's what I'm saying. They will not going to ask what is local maximum, but they can ask what is the maximum value of the function.
Yes, sir.
They will give you the graph. They will say in what point you are getting the maximum value.
Basically, A, sir, quadratic equation का जो A होता है.
Yes, you have seen this minus b by 2a, no?
Yes, sir. जो
Here
A
you will
sir.
get maximum or minimum, depending on the point, like depending on the sign of a.
Yes, sir.
If a is greater than 0 or less than 0, right? That's what I am saying. You got my point?
Yes, sir.
So if they will ask some maximum point, so the maximum will be come from here only. Okay. Though don't worry about it. This thing will cover on the week 7, week 8. Whenever you will discuss about local maximum, local minimum. But still, I just want to give the idea. So you understood the maximum value. If you want to find the maximum value, this one. Minimum value, this one. At this point, you will get the minimum value. Okay?
Sir,
Yes, sir.
Sir, I have the follow-up question for this. Like, I get the concept of like the local maxima and local minima, sir. But like, in quiz for like in week 4 assignment, there was a question. Like we were given a function. So like the function was x minus 2 whole square, into x minus.
Can you repeat it again?
X minus 2 whole square into x minus 3
into x minus 3
into x plus 1 whole square
into x plus 1 whole square
into x plus 4
into x plus 4
into x minus 5
to x minus 5. Yes, this is the question.
Yes, and sir, the coefficient of it was minus 1 by 300.
What coefficient?
Coefficient, like you can just multiply it one more by minus 1 by 300.
Fine.
300, sir. 300.
What are the roots?
Sir, so basically this was the multiple type question. So in this, there was one option where it was given in the interval x belongs to 3, 5. F of x is increasing first and then decreasing. Sir, so
Okay, let's see the graph. Okay, let's try to see the increasing and decreasing part of this question. Okay.
Yes, sir.
Yes, sir.
For
So
this,
like, sir, the challenging part for me was like how to graph that equation like that. I didn't really got that.
Okay, that's the thing. What are the roots? You know what are the roots? This 2, 3, -1, -4, and 5. I think this question is made by me itself. Okay. -4, -1, and 2. I don't think so. I don't think so. This question is made by me, but it's looking like the question like me. Okay, so this is 2, 3, 5. These are the roots, right?
Yes.
Yes, sir.
Now, how will you make the graph? See, because of this sign, if you will suppose try to put one value, suppose 6, if you will put 6 here. Now, if you will put 6 in this point, like if you want to see the value of f of 6.
Okay.
What it will be?
Sir,
I
you
am
will
not talking
you will
about
put
what will be the exact value. I am just talking about what will be the sign.
finite होगी sir.
No,
It will
not
be
finite.
positive.
It will be why it will just forget about this -1 by 3 part. Just look at this part. If
Because
here will be
squaring of
6,
that number.
just listen to me carefully.
Okay, sir.
Okay, just listen to me carefully. Then I will ask you whatever thing. If you will put x is equals to 6 here, this will be positive. 6 minus 2 is 4, positive 4, and still here square is there. No worry. Okay, let's discuss about this 6 minus 3. It is positive.
Yes.
X plus 1. It means 6 plus 1. Positive.
Yes.
6 plus 4. Positive. 6 minus 5. Positive.
Yes.
It means that if I will exclude this -1 by 3 part, this whole thing will be positive, right?
Yes, sir.
Now, include this -1 by 3 part. It means that f of 6 is less than 0. Negative.
Yes, sir.
Yes.
Right? It means that the value of this up to this 5 is coming like this, no?
Yes, sir.
It is going towards -infinity as x going to infinity. Because since there is no roots in this way after 5, so this function cannot move in that way.
Okay,
Right?
sir.
This function cannot move this kind of thing, because there is no such root. So this will go by up to plus infinity as well. Right?
Yes.
This is your y-axis at 0. Now, once you reach 5, just check what is the multiplicity of 5.
1.
1. Odd. So it will cross the axis.
Yes, sir.
Right? Now, cross the axis and then reach to 3. Now, check what is the multiplicity of 3. Here is 3.
1.
1, right? It will cross the axis and then reach to 2. Now, see, what is the multiplicity of 2?
2.
2. So it will again
Bounce back.
move towards only.
Bounce back.
Bounce back, right? Yeah, Vivek Bandra wala bounce back.
Okay.
Yeah. Have you heard of that controversy?
Yes, sir. Yes, sir.
Okay.
Yes,
So
sir.
it will go to -1. What is the cardinality of -1?
Square 2.
It will
Sir,
again bounce
will
back.
again bounce
It
back.
will again bounce back. Okay.
Again bounce back.
Now then see like this. What about this -4?
Sir, single.
Cross
Sir,
the axis.
it will cross
It will
this.
cross the axis, right?
Cross this.
Easy. Now this is the moti graph. Okay. This is not looking like a graph, but it's a graph. Just assume that.
Okay.
Okay. Now my question is, what is the increasing and decreasing thing? So there will be some question like, in that reason the function is increasing or not, that kind of thing, or they will give you some union like this, because what point you will get the peak, it's very difficult to find right now, right?
Yes, sir.
Right? So I don't think so they will ask for that, because for obtaining this peak value, you need to learn about the differentiability concept. Otherwise, just looking the graph, either they will give you like this line. Yeah, they will give you reference like that. Now you will be able to find the value, because here they will give you some point. Here they will give you some points like that. Suppose here they will say, yeah, 5 by 2. 5 by 2 at 5 by 2 you are getting. So you motamoti you are getting my point what I am trying to say.
Yes. Yeah.
Now after making the graph you will be able to find in what interval the function will increase, in what interval the function will decrease. So basically decrease I have not defined yet, but still I think you got the idea what will be the decreasing
So this
function,
one is
right?
from polynomial pattern, sir.
Yeah, this one is from polynomial part, but still in the function part, I am just trying to cover, because tomorrow's session, I don't think so there will be much student,
Sir,
because
one thing.
it's a morning session. Yes.
In the interval -infinity to -4, it will be decreasing. It's strictly decreasing, right?
Yeah, right.
Yes, yes,
Okay.
yes, you are right. Now
Okay.
you got my point, I guess.
Yes, sir, absolutely.
So let me write the decreasing definition. I haven't write yet. Decreasing function. So what is decreasing function? If you are x1 and x2 like this, and this implies fx2 is less than or equal to, no, fx1 is less than or equal to fx2, then we will say it's a decreasing function for all x1, x2. Okay, got the point?
Yes,
or not?
Yes, sir.
What will be the graph is look like? If you will move this direction, your function is decrease like this.
It will go to
Okay.
minus infinity.
Like this. Yeah, it will decrease. Like if you will take 2 points here, then see this length will be higher than this length. That's what I am trying to say. Got the idea of increasing and decreasing function?
Yes, sir.
Yes, sir.
This part is important.
Yes, sir.
There is a possibility that one question will come from here.
Okay.
That is why I am explaining this thing. Okay. So up to this, week 1 is completed. Okay. Now don't worry. The next part will complete it by 1 hour. We barely take 1 hour because it's just a formula thing. Okay.
Okay, sir.
It's just like the question will be coming from week 2, like formula lagao, answer lao. Simple.
It would be
Sir,
purely formula based.
Sir, I have a question.
Would it be purely formula based?
Pretty
Yes.
much.
The week 2?
Yes, sir.
Yes. Basically, it will be the formula based only.
Then formula, okay. Yeah.
Sir, I have a question from graded assignment week 1, last
Yes.
question.
Yes.
It,
You just paste the question. I will take that.
yes, sir. Sir, I have already pasted it.
Where?
I can share my in the chat box.
What's your name?
Zuniera.
It is not there in
just-
Google.
Please take
just
any screenshot.
paste it
Okay.
again.
Okay, sir. I'm
This
pasting.
consider the function. Please take the screenshot and then paste it.
Okay.
Otherwise, if you will take the, like, if you will copy and then paste, it's very difficult for me to recognize the thing.
Okay,
And
sir.
for everyone as well.
Okay, sir. I'm doing.
Please do pause.
Or she
Okay.
can share the screen also.
I don't think so. She can share the screen because she is not.
She can't share. Yeah.
Okay. So this here, as you can see, you just says, okay. You just share Junaira, then we will see. Now distance formula is there. So what is basically distance formula? If you have 2 points like x1 and x2, x1 y1 and x2 y2, then the distance, the shortest distance between these 2 points is given by this. And then someone will say, sir, how did you got this point? So I will tell you how did you got this point. Suppose this is your point P1 and this is your point P2. This is your x1, x2. It can be anywhere in the space, okay? And this is, okay, x1, y1, and this is x2, y2. Okay? And you need to find the shortest distance of these 2 points. What does this mean, the shortest distance? It means that this distance. One line only, right? But it is happening on the plane, right? Only. The distance between 2 points is just is the straight line in the plane. not in the surface like this. Okay, like sphere and all. So in the plane I am talking about. Okay, so you need to find the value. Yeah, I have seen. Just let me complete the distance of between 2 points. I will take that. Okay, so you have to find the distance between these 2 points. How will you find? This is your P and this is Q. Now, you can draw the line like this now. Right? Give it name M. Right? You can do like that now?
Yes, sir.
What's the thing? You need to find this value. Now, you have this length. Just apply the Pythagorean theorem here.
Pythagoras
You
theorem.
will get that because this is the right angle.
Yes, sir.
Okay, you will get the formula. And what is the formula? Formula is defined like that: x2 minus x1 whole square plus
by 2
y2
minus
minus
y1
y1 whole square.
whole square.
This is the distance between 2 points. Okay, simple.
Yeah.
Okay, let me share. Are you guys able to see this question 10th?
Yes, sir.
Yes, sir.
What is this question is saying basically?
Consider the function f plus 1 ta.
Okay. Consider the function f which is defined from natural number minus 0. It means that, but I think this question is already covered. This to same set. Okay. 1, 2, 3, 4. I have seen this question somewhere. Same question. Okay. So what is the question? This is your function fx. This is your function gx. See, fx is equal to x plus 1. We have already seen it's a 1 function, right?
Yes, sir.
Yeah.
Right, Junaira?
Yes, sir. Yes, sir.
We have already seen it's a 1 function. So f is a 1 to 1. This is okay. So this is incorrect because here he is saying f is neither 1 because f is 1 we have already seen.
Yes, yes. Yes, sir.
Okay.
Yes, sir.
Let's discuss about onto whether it is onto or not.
Yes, sir. That
Okay,
part is
so
to discuss.
fx is equals to y. I have said to tell you. Take fx is equals to y. X plus 1 is equals to y. Then y is equals to no. Then x is equals to what?
Y minus
Y minus 1. Okay.
Yes. Yes,
This is
sir.
also there. This is also there in n minus 0 or not? No, right? Why? Because if you will take
Because
y is equals to 1 here,
yeah.
Yes,
if you
sir.
will take y is equal
X
to
equals
1,
to
your x
0.
will be 0. But 0 is not inside this set.
Yes, sir.
Not on 2.
So
So
that's
first
why
one
not
is
on 2.
correct. Second was incorrect because he is saying not 1 but it's a 1 function. So second one is incorrect. The first one is saying f is 1 1 we have already checked, but not on 2. So not on 2 because for 1 belongs to this set, I am not getting any value from this n minus 0 because what are the value it is? It is 0, but 0 is not inside this. So this is not on 2. Okay.
Yes, sir. Okay, sir. Only this thing I wanted to clear. Thank you.
Okay. Gx part will be is clear to you?
Yes, 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 yes.
Okay.
So please
Thank
once again, sir, explain this GX part.
Gx is what? Fx, just put the fx value here. What you will get? X plus 1 minus 1. So what it will be? X only, right?
Yeah, so x if x is x greater than 1.
Yeah.
So could you
This is
repeat
the
the
function.
reason why this f was not onto?
Because for 1, if I will take this value from your codomain.
X0, yeah. Oh, yeah, got it. X will get violated because input has to be natural number besides 0.
Yes.
But it will equals 0. Yeah, got
Yes.
it. Thanks.
Okay.
Yeah, thanks.
Okay. So up to here, got this idea? Okay. What are the formula we are discussing? Each formula are important. I don't know from where this they will ask the question. Okay. This just a formula based question. No concepts are there. Okay. What are the concepts are there? We have already discussed. So for the this distance between 2 points, I have discussed from where you are getting this formula, right? That is okay for everyone.
Yes, sir.
Yes, sir.
Now, what about this section formula? Basically, section formula, how will you remember? Right now, this is the important thing. Sir, how will I remember the section formula? I am always confused. If you have point P here, Q here, suppose P is your x1, y1, Q is your x2, y2, and another point is here, suppose what R. And this R is intersecting this line, like by the ratio mn. Okay. Okay. Then what will be the coordinate of R, x and y? So the coordinate of x, like the x will be given by like this. Put this m and take the opposite one. Okay, not this one, that one. Then write mx2 plus. Put this n and take the opposite one, nx1 divided by this m plus n. Easy. Similarly for y. Similar case for y. Put this m and take the opposite one, my2 plus. Put this n and take opposite one, ny1 divided by m plus n. Easy.
Yes, sir.
Yes, sir.
Now the thing is, if both like this R will cut this PQ, like this line segment PQ into equal parts. It means that if m and n are equal, then just put midpoint rule.
Yes, sir.
So it will be mx2 plus mx1 divided by m plus m, right? I will take m as common. So what I will get? x2 plus x1 divided by 2 only.
Yes, sir.
Right? M will be cancelled out. Similarly for y you can do. This is known as midpoint rule or midpoint formula. Easy?
Yes, sir.
Now you can easily remember. They can ask one question from here itself. Okay, where is the slide? Okay, so this part is done. Okay, similarly, see, if your point is outside, don't worry about it. Okay, same thing is there. But the thing is, this minus portion will be there. Why this minus portion will be there? Because from getting this point, you have to. Sorry.
Nothing, sir. Nothing.
Okay.
Continue.
So why this minus portion is there? Because you are going extra n times, no? N part you are going extra. So you have to manage that thing. You can remember like that. Right? If you are this P is intersecting outside, you are moving this n extra, right?
Yes, sir.
Right? Same. So for extra, you have to minus this thing. That is why you are using minus here.
Got it, sir.
Got it?
Yes, sir.
Okay. So the thing is same thing. N x1. Okay. So the bigger one. Sorry. Here xy he is using. Okay. mx2. Okay. mx2. Yeah. mx2 minus nx1. Okay. If you don't want to go by this way, but you cannot solve by this way. Okay. Okay, leave it. You can go by that way only. This m, yeah. This m, the bigger one with this one. Okay, this n with this one. Okay. Basically, you can say, where is it? In this formula, this plus will be removed by minus only. Okay, simple.
And if we have midpoint here, then it will be same with the minus sign.
Yes. No. It cannot be midpoint, right? Like that.
Yes, sir. It can't be midpoint.
If
Right.
there will be the same thing with minus sign, the denominator part will become 0.
Yeah, not
Okay.
Yeah, okay.
We will not allow. See, simple thing is there. If midpoint you are saying if M and both are equal to each other, right?
Yes, sir.
Where is that point? In that case, what is your N from P to B distance? Suppose if you are taking like at distance, so the ratio is from P to N. Okay, what is your M? The ratio is from P to A, right?
Yes, sir.
Right? Now, if N and M both are equal, then your this B point move to A only.
Okay.
Yes, sir. Yes, sir.
Right? This B point will be there in A.
Okay,
How will you find this P? You are not able to find the P, right? In this case.
Yes, sir.
Because this B and A both will become same point. Okay.
Yes, sir.
Yes, sir.
Now,
Got it.
here, this is the formula area of triangle. You have to remember. How will you remember that? I will let you know. I will not going to explain from where this formula is coming, because it will take too much of your time and this is not necessary basically. Okay, so see, first of all, half you have to remember, and whatever thing is inside it has to be, you have to take absolute value. Now, if you are taking x1 here, then you will take 2 and 3, y2 minus y1, then x2, then 3 and 1, basically in the circular order. This is your triangle. Okay, this is your x1, y1, x2, y2, and x3, y3. Okay, so inside the modulus thing, how will you check? Once you put this x1, take minus of y2 minus y3. Now, move towards this. Put x2 with addition. X2. Now, I am taking this x2. Now, go y3 go with y3 minus y1. Okay, I am going with this direction only. Okay, y3 minus y1. Okay, plus. Now, move towards this x3. Now, if you go x3, then take y1 minus y2. I am moving towards this direction only. Right? Easy. And then put 1/2 there.
Yes, sir.
Very easy, sir. Very easy.
Sir, so how will the question be framed by this formula? Like
This formula, they will give.
Yeah.
See, two types of question will come from this formula. Basically, what they will say, sir, what I am trying to say, sir, there are 3 points. Find the area of this is a very simple question. They will say find the area of the triangle which is made by which edges is given by this. Or they will give you some Kriya Karam kind of thing. And in that Kriya Karam, you have to find the value of this x1, y1, x2, y2, and x3, y3. Okay, if they want to make the question hard, the question will be obtaining the value of this x1, y1, x2, y2. This point basically p, y, q. Okay, and once you got this point, they will say, yeah, what will be the area of that point? Okay, so basically the question will focus on the finding this point. Once you find this point, they will say what will be the area. This is one question.
Yes, sir.
The
One
area
point
will be
will be
given.
missing and we have to find equate.
Area will not be
Sir,
given. There will be some condition. From that condition, you will get this point. Okay, from that condition itself, you will get that point. Okay, if they want to make this question as a numerical way, you cannot write the points in the answer sheet, right? In the numerical thing, you cannot write. So they will say, yeah, you got the point now. You got the point. Just give me the area of that triangle which is making by which edges is these 3 points. Got the
that I
point?
got. Sir, that I got. But what you told about like that complex thing, if like there will be unknowns. I mean like a y1 or y2 or any value will be unknown. So, sir,
Uh-huh.
like if there
What
are
kind
unknown,
of
I
condition it
think
will be?
yeah. So like, can you like
Okay, so
please briefly explain that one?
basically in the section formula also they can give you the condition, right?
Right.
They will say, yeah, you have these 2 points and the point xy which is dividing these 2 points by this direction. Now you can find this xy. They will give you another condition on the distance from the distance formula.
Yes.
They will give you the distance. Okay, they will give you 1 point. Like suppose they will give you the value of x2. They will say what will be the value of y2. What will be the possible value of y2? So from the distance formula, since square is there, there will be two possible value for y2 or x2, whatever it is. So from here you can get two different points, right?
Yeah.
Right. 2 points are from there. 1 point from there. You got 3 points.
Yeah.
Now conditions are there for getting 3 points. Now they will say, yeah, you got the 3 points. Now give me the area of triangle by that 3 point. Whose edge is this 3 point? Okay,
Yes.
that kind of question. Now, condition they can make according to them. I am not saying these are the only condition, but I am just giving you the example. This kind of condition will be there will be. Now, what kind of question? I am not saying question will come like that only. I am saying if the question will come from the area of triangle, that question will become like that. Okay. The another part will they will say, but this is not the ideal way, but still I am saying they will ask you the question like that. Yeah, they will say, yeah, these are the 3 points where just check whether these points are collinear or not. Okay, if the points are collinear, then this area will be 0.
Yes,
Collinear,
sir.
what does it mean? Collinear.
Yeah.
Collinear
They're all
means
in the same line.
these 3 points are lying in the same line.
Same line. So there is no area.
Okay, so
their
okay,
slope
so
will
the
same.
area will
Slope will
be
be same,
0,
right?
right? Yeah.
Yes.
In this case, slope will be same also. But yeah, this is another way to checking this. This is your triangle. What you are doing, you are pushing this one to this point. Once you got this, the area should be 0. Got the idea?
Yes, sir. So, can you take me back to that formula?
This one.
Yeah, so it can be easier to remember this formula by looking at y3 is with y3 in the brackets, like adjacent, and y1 is with y1. So the rest will be y2, y2 on the outside.
You mean
Like
taking the
Y1 with Y1
determinant?
where?
like,
Are you
there's a
taking that?
pattern. So it's like y3 from the
Sorry,
first
I
bracket.
am not getting your point.
Okay. Let me just. So y3 from the first bracket.
Y3 from the
first bracket
okay.
is adjacent to the y3 in the second bracket. So it's like if you make it's like an arc. Yeah, like y3 is so y3 and y3
Yeah,
and
you
then
can see. Remember, it's it's up to you now how you are remembering the formula. I have shown one
It's
way
easy to
by this cyclic form.
it's easy to remember 23, 31, 12. It is very easy.
That is also you can do it. It's
Sir,
only up
can
to
we
you.
take
Okay.
like determinant of the matrix and like that's also an approach,
Sir,
right?
we have to take the points in the anti-clockwise direction.
Yeah, you can take. See, I am just showing the one
Only
way.
in
Okay,
that
you
case you
can
will get
take.
the correct.
You can. No, you can take clockwise as well because
No,
here
in the
you are
lecture,
getting the positive value, the
sir has
absolute value.
pointed. In the
So I
lecture
feel
also,
the
sir
determinant
mentioned that
approach
There
will be
will
the
be
easiest.
1,000 ways of remembering this formula. Like there's no point of like discussing this.
Yes, no point of discussing. See, one doubt I
Very
will
much
clear.
out
You can
around.
take the clockwise direction as well. See, what happened in the clockwise direction if you will take this y3, this term will become y3 minus y2. This term will become y1 minus y3. This term will become y2 minus y1. Take the minus out because of this absolute thing. That minus will become plus. Again, the same thing will happen. Got it?
Yes, sir.
I'll check and come back to you.
Continue further.
Sir, it's basically the determinant of all 3 points matrix.
Yeah.
Okay, we are not going to discuss determinant here, so please don't mention that thing. Okay, you got my point. Someone was okay.
Yes, sir, it's clear.
But
We can move forward.
okay, okay. But the caution is once you choose the one direction like clockwise direction or anti-clockwise direction, you have to complete by that way only. You are not allowed to again choosing like you are saying, sir, I will put firstly anti-clock like clockwise direction and then I will go with anti-clock direction. Like here you have done y2 minus y3 and here you are doing y1 minus y3. That will not going to allow. Like, you got my point? Here
Yes,
now,
sir.
once you choose the one direction, like either clockwise or anti-clockwise, you have to follow for all process. Okay.
Yes, sir.
Okay. Let's move
Yes,
forward.
sir.
Yes, sir.
Okay. Now, slope of the straight line. It's easy. Slope of the straight line is given by tan theta. Tan theta is basically this angle. Okay, with the x-axis, which is given by, you can find this by 10, like that base, like what is that? Height by base formula. This is y2 minus y1, this is x2 minus x1. So what will be the tan theta? Tan theta will be y2 minus y1 divided by x2 minus x1, height by base.
Yeah, yes, sir.
Right? So this is the slope of the line. Okay, this is also very important because this slope of the line will be helpful for the further question as well. Like in the quadratic equation or whatever it will be, this formula will use in the several times. So this is also important. Like
So
each and
for
every formula.
this
Yes.
thing, but there were few questions that required some of the trigonometric identities. Do we need to focus on that?
In week 1 to 4, I don't think so. In week 1 to 4, I don't think so there will. But after upcoming weeks, yeah, you need that. Yeah, this characterization, this is very important. If two lines are parallel, then the slope will be equal. Okay. In that case, how what kind of question they will ask? What they will say? They will give you they will give you a equation of line. Okay, and they will say you the another line is parallel to this line. What will be the slope of that line? This is the simplest question. Okay, they will they will modify that question in the tougher way as well. Okay, right now I like anything is not coming inside my mind. What kind of question it will be? But yeah, they can modify it like that.
Yes.
But somehow, if the parallel thing is come, you have to focus on the slope. The slope will be equal. And
Yes,
if similarly perpendicular also. So what kind of perpendicular? If they want to confuse, they will say the angle between L1 and L2 is pi by 2 or 90. Once you got this thing, it means that perpendicular thing they are asking, because perpendicular is what the angle between
Pi by 2.
L1 and L2 is 90. Otherwise, once you see, yeah, sir, the angle between two lines are this, so I will apply that angle between two lines formula. No need to apply. Okay, once you got this, yeah, right angle are there. So you can you know now this formula m1 and m2. So the slope of another line is just reciprocal of the first line. So
Can you share your
negative.
PDF of this section after this section?
This PDF.
Yes, sir.
This whatever, yeah, this will I will say. Okay. Now this is very important. Okay, this is very important. You can write it as 5-star thing. Different form of like equation of line, and it is similar, easy to remember. This is the general form ax plus by plus c. Okay, now slope point form, it means that if the line you have given slope and one intersection point, like one point where the line is passing, so the slope of the line should be go like the line or equation of the line will be defined like this: y minus y naught equal to mx minus x naught. Similarly, if you have slope and y-intercept, then the equation of line will be given by this: y is equals to mx plus c. If you have x-intercept, the slope of the line will be given by this. And according to the intercept form, it means that if you have a x-intercept and y-intercept, the slope of the line will be given. Sorry, not slope of the line. The equation of the line will be given by this. If you have 2 point, the equation of the line will be given by this. Okay, this is very, very important. Okay, if you are sleeping and I will ask in the
No, sir.
Sir, it's okay. We understood.
No. I'm just giving you an example. Like if someone will ask in your sleep. So in that case, also you have to just wake up and then say, yeah, you want to know the x-intercept form of the line. That formula is given by y is equals to mx minus d. Okay, that kind of formula they are.
Okay, sir.
Yeah, I'm not saying you are sleeping or not. Okay, angle between two lines. So this is the formula is given by this. I will not going to tell how this formula is coming. Why? Because of explaining this formula, I have to mention some trigonometric identity, which I am not going to mention right now. Okay, just remember this thing.
We will not have any trigonometric identity question, right?
Sir,
yeah, right
there
now.
is tan A minus
But
B
right
formula.
now
we will not have, right?
Yes.
Okay.
But in week 4, 5, you will get.
Yeah. From
Yes.
1 to 4, we will not have it.
Sir, the TI, I mean, I think it was told that at least if you can remember something about the tan will be helpful, if at all.
Yeah, this is just a tan.
So just tan theta
like tan
values.
inverse. Yeah, tan A plus B formula, I guess. If someone has remembered that thing. Tan inverse formula. That
Tan A minus B formula.
Yes. Okay. So I will share the PDF. Just see this thing. What time is tomorrow's revision class? It's 7 to. It's started from 7. Ayush. 7 in the morning.
Okay, 7 in the morning. 7 in the morning will be 2 maybe here where I am. So it is very inconvenient timing.
Yeah, it's like it's
2
for
at
everyone. Like
night.
it's for
2 at
not
night.
9.
It's here
No,
because
we
I'm
can't.
not in my
It's see. I am also not a morning person, or I don't think so. What about Vishal sir? But I am not a
Where
morning
can I
person.
find
So
the PDF?
I will share in the chat box itself in the last of the class. Link is there. I think you will be able to find the PDF. Just let me know if the link will open or not. Okay. Okay, don't worry. I will close this. I will try to close this session by 12:30. I cannot say 12, but 12:30 I will try. Okay.
Okay.
But still, I have a class at 8 o'clock, I guess. Yes, 8 o'clock. So I have to wake up early in the morning.
Okay, sir, let's move.
Not the BS program class, my own class. Okay.
Okay, continue.
Sir, are
Okay,
you
continue.
are you doing MSc?
Yeah, I am a master's student, master's in mathematics student from IIT Madras. Okay. That's not the point. We have to complete this. Otherwise, what will you write in the exam?
Yes, sir.
Okay. Won't you be taking our class tomorrow? No, I have to take my classes. Okay.
Okay, so thank you.
Because there are some attendance criteria. I have to fulfill that. And I have already missed so many classes. So I have to attend.
Sir, I think it's going to be 1 a.m.
Sorry?
1 a.m.
Sir, I don't know what
The
it
class
is.
will not going to 1 a.m. Don't worry. I don't think so. The most simple, but the 2 slides are remaining only. I
Do
don't
it
think so it will
then.
go.
Just complete now.
Yeah, it will complete.
So this conversation is going to be going into YouTube.
Yes, sir.
Don't worry. Don't worry. There is no some like I don't think so. There will be. See, session will be like that only now. Otherwise, people will be bored and they will be feel sleepy.
Yep.
Yes, sir.
Okay, this is basically one-to-one interaction kind of thing.
Yes, sir.
And you are learning something that's important. That is why session is the duration of the session is long now. And see, the thing is, if I okay, forget about it. Let's read it further. When it will be between 7 in India here, it will be 2:30 a.m. I am not getting your point.
Sir, I am saying that to attend the live class in early morning in India, according to Indian timing, it is very difficult for those who are living outside India and in different time
Is there
zones.
anyone who is living outside India?
It is me.
I think she is.
So yeah, so even me, so. But it's okay, like, I mean, I'm staying up, so it
Where
doesn't
are
matter.
you from?
Sir,
So I'm
I
from
am
the
from
girls' school.
Sorry?
I am
Where?
from Germany.
You are in Germany right now.
Yes, it is 7 o'clock in the evening right
Ah,
now. So it is
okay.
But here
Sir,
11:30 p.m.
continue, sir.
Okay. Okay. But
you
you
must
somehow
be
you
late.
have to manage. Okay, you have to
Okay,
manage. We
okay,
don't
it's
have
okay.
anything in our hand.
It's
Okay.
okay.
Okay, so condition for parallel and perpendicular lines. What are the condition? Given two straight lines, say these are the two straight lines. I think this thing you have learned. This thing you have learned in your 10th class, right?
Yes, sir.
That
Yeah,
no
sir.
solution, infinitely many solutions. Had you heard about it? If lines are parallel, then the solution, there will be no solution case,
Yes, sir.
Yes, sir.
right? So basically how this thing is come, like from where this thing is come, I will let you know, because now I have 1 hour, so I can explain from this list. You have a equation a1x plus b1y plus c1 is equals to 0, and a2x plus b2y plus c2 is equals to 0. These are the two line condition. Okay, just write it as in the slope form. What it will be? Y is equals to what? Minus a1 by b1 x minus c1 by b1, right? For the first statement. And what about the second equation? Minus a2 by b2 x minus c2 by b2. How I am getting the, are you able to understand? I am just finding this y value. Right? If you have any doubt, please ask.
Yes, sir.
Sir, the slope of line is m is equal to ax plus c now. Like
Yeah.
how
Now
can we
this line, this equation is of line in the form of this mx plus c, right? And this m is given by the slope. So for the first line, suppose this is your L1, this is your L2. For the first line, what will be the slope? M is equals to minus a1 by b1. And for the second line, m1, say m1. For the second line, what will be the slope? Minus a2 by b2. Now up to this, if you have any doubt, please ask. No doubt?
No,
Why
sir.
does L1 have common denominator?
Where common denominator? See,
B1.
if you will find here, if you will separate b1y here, what you will get? Minus a1x minus c1, right? Now find the value of y. For that, you have to divide this b1.
Okay.
And similarly for this. So here, now if L1 and L2 are parallel to each other, what will be? It will be, their slope will be equal, right?
Yes, sir.
Yes,
Now
sir.
m1 will be
M1 is
equal
equal
to
to M2.
m2. It means what? a1 by b1 is equals to minus a2 by b2. Thus,
Yes, sir.
do the cross multiplication. What you will go? Get a1 into b2. b2 is equals to a2 into b1. That's what here written
Parallel.
here. a1 cross b2 equal to a2 plus b1 in the parallel case. Got the idea?
Yes, sir.
Now, similarly, if the lines are perpendicular to each other, if L1 is perpendicular to L2, then M1 into M2 is equals to what?
-1.
-1. It means what? minus a1 by b1 into minus a2 by b2 equal to minus 1. Okay, so what is this basically? This is a1 into a2 is equals to minus time b1 into b2, right?
Yes, sir.
Now this is what written here. a1 into a2 minus time b1 into b2. Got it?
Yes, sir.
Okay, so here another formula. If you have a distance of a line from a given point. Okay, so this is what is basically. Suppose you have a point and you have this line. Now, the distance between this point and this line. This is also in distance. This is also in distance. This is also in distance. So what distance you are talking about? So the smallest distance. Okay, remember the thing. The smallest distance from this point to this line. Okay. So suppose this point is your xy and this line is given by ax plus by plus c is equals to 0. Okay. The line is in its general form. So this is the point. So what is the smallest distance between this point to this line? It will be given by, if I will draw a perpendicular in this line from this point. So I will get that point, right? I will get the distance, that this distance will be the smallest distance.
Yes,
right?
sir.
Yes.
Right. So that distance will be given by, okay, that distance, suppose this is point M. Distance will be given by this. Just take A, remove this X. Okay, suppose this is X1, Y1. Otherwise, you will confuse. This X1, Y1. So AX1 plus PY1 plus C divided by this coefficient A square plus B square. Okay. You need to remove the, like, you need to exchange this X and Y by X1, Y1.
Yes, sir.
Okay.
So that is the length of that is a displacement like PM.
No, yes, you can say like the length of the distance basically.
PM is
The
distance, right?
shortest, yeah, the shortest distance between P and M. Or the shortest distance between P and this line. Okay, because the distance between the P and line will be given by this line as well, that this distance as well, this distance as well, this distance as well. So here we are talking about smallest distance. Okay.
Okay, sir, got it.
This is the one. Yeah, and you need to take the modulus thing, so-called modulus thing. Okay, now you have distance between two parallel lines. Suppose you have a line this, then the distance between two parallel lines is given by this. Okay, this C1 minus C2 divided by A square plus B square. Easy, no? I don't think so. It's a very big deal.
Yeah.
Yeah.
Okay, now the most important part is here, some squared error. Now, how many people have some doubt in this? Please let me know so that I will explain like that. This is the last topic, SSE. Squared sum error, some squared error. This is in stats as well, I think.
So this is in
Please
week
explain
4.
from the start.
Sir, can you explain this?
Some squared error. No? See,
Yeah.
if you really want to, I am again saying, if you really want to like watch this kind of this sum squared something in a very deep way, I am suggesting you please go and watch that Solve with Us week 2 session. Here, there I have discussed only this thing in the like 1.5 hour. In the duration of 1.5 hour. From the initial, why we are using this, how this thing will come, this kind of thing. Okay. Now I am explain this. I will explain this thing, but I am not going to that way. I will just give you the
Sir,
motivation.
I have watched all your lectures, but here, can you please explain again?
Okay.
So for the graded in the week 4, there was a question. Like, I don't know what error I did, but I'm getting the wrong answer.
Can you paste that question in?
I have done.
Yeah.
Sir. Done, sir.
You have done that question. Okay, still please paste that question so that I will solve that question here itself.
Okay.
For others.
I'm done. I have done some means that I have put it in the chat.
What's your name?
Ankit.
Ankit, this one, right?
Yeah.
Okay, let me share the question. Can I explain this sum squared concept with the question so that it will be easy for you?
Yeah, sure, sir.
Okay, sir.
Yes, sir. Yes, sir.
Because definition you can read now, read from there. I am explaining how will you find the solution. This fourth one, I don't think so. Okay, this is the thing. This is the question. But in this case, if you will talk about the sum squared thing, in this case, we will discuss for linear function. Here, this is the polynomial function, but for week 2 case, we will discuss for linear function. Okay. So what is this basically? What this question is saying? This question is showing a function fx, which is okay, a function fx which is the best fit for data given in the table 1. Okay, so first question is, what does this mean best fit? What does this mean best fit? Okay, table 1 recorded by the student is this. This is the function. Now you have to find this value c, I guess. What will the value of c? For that, this thing will be minimum. The sum square error will be minimum. So basically, what is sum square error? Sum square error is defined by this. See, here two terms are there. Sum squared and then error, or squared sum error. So you basically what you need to do, you have to do some sum of some squares, that kind of thing. So suppose you have some initial data like this. Here you have some data, right? Some table kind of thing. Right?
Yes, sir.
Okay. Yes, sir.
Right?
Yes, sir.
Here you have some, suppose this is your y1, this is your y2, this is your y3, this is your y4, this is your y5. Okay. Now for each x you have assigned y1, right? Yi's, for each xi's you have assigned yi. This is your
Yes.
x1, this is your x2. Now how will you check what will be the sum, what will the square error? So basically this function is what? This function is predicting the value according to this x. Okay. This function is basically what it is doing. It is predicting the value. Predicting, it means that it is approximating the value. It is just give you the prediction. What will be the value whenever you will put x is equals to 5. We know the exact value. It will be 3. But according to this function, what will be the value? So it will be given by f5. The function will say, will say, yeah, the value of this data at 5 will be around f5. Like there will be some error. What will be the error? That we need to calculate. So that error will be given by f of xi minus yi, or you can sometimes they will say yi minus f of xi, whatever it is, because square is here, you can interchange both and take the sum. I is equals to 1 to 5. Here 5 elements are there. That is why I am taking 5. Okay. You are getting my point?
Sir,
Okay.
I did the
Yes,
same,
sir.
but I was getting the wrong answer. That's
Sorry?
I did the same thing, but I was getting the wrong answer, so that's why asked this question.
Yeah, I will let you know what will be the answer. So what I need to check, I have the function. I need to find the value of c for which this error will be minimized. So basically, I want to approximate this function such as this error term will be as minimum as possible. Okay. It is my agenda is to minimizing this error. So firstly, let us know what will be the f of 1 value. What will be the f of 1 value? If I will put 1 here, I will get 0. So I will get c only, right? Because this term will become 0 because of x minus 1.
Yes, sir.
Right. If I will put 2 here, what will be the value of f of 2?
15. Let's see.
2 minus 1. Minus 1 is okay. Here, if I will, this x minus 1, in terms of x minus 1, if I will put 2 here, what it will be? 2 minus 1 is 1. 1 square is 1 square. Okay.
1
Now, if I will put 2 here, it's 2 minus 3. It's minus 1. Okay. If I will put 2 here, what it will be? 2 minus 5. It's minus 3. Here, if I will put 2 here, 2 minus 7.
-5.
Minus 5. And plus C here.
Plus C.
Okay, minus 5. And plus C. So what will be the value? Minus
15 plus
15 plus C.
5, 3 is 15. Okay, 15 plus C. Now, if I will put 3 here, if I will put 3 here, this again will become 0. So f of 3 is 0.
Right.
Right?
Yes.
Now, what about the f of 4? I have to calculate. Minus 4 minus 1 is 3 square. Now,
9.
4 minus 3 is 1. 4 minus 5 is, sorry,
Minus
minus 1, right? No, 1 only. 4 minus 5 is minus 1.
-1.
4 minus 7 is
-3.
minus 3 plus C. What it will be? 27. Minus 27
minus 27
plus C. Okay?
Okay.
Okay. Now, if you will put x is equals to 5, it will be 0. So, f of 5 will be C only.
Yeah, f of 3 also should be C, not 0.
Yes, C. Now, you got this value?
Yes, sir. Values matches.
Right. This is the value. Now, you have to like evaluate this one. F of, shall I write here? Where is the one? Yes. Now you need to calculate this. I is equals to 1 to 5. F of xi minus yi whole square. So basically what? F of f1 minus y1 whole square plus f of f2 minus y2 whole square. See, this 1, 2 is coming from the input value, okay? Where is it? Oh, this one. Yeah, this input value I am taking f of 1, then f of 2. If this 3 is nothing apart from this 3, if there is 7, then I will take f of 7, okay? This
Yes,
is
sir.
not like that, okay? So got my point, no?
Yes, sir.
Yes.
Now plus f of 3 minus y3 whole square and up to f of 5 minus y5 whole square. I need to calculate this value. What is the value of f of 1? It's C, right? C minus. What is the value of 1?
4. It's 4.
Just a minute. Just a minute, okay? Okay. So it's 15 plus C. I'm confused. Okay, C minus 4
Sir, 4
whole
C
square.
minus 4.
Okay, plus. What is the value of F2?
F2 is C plus 15.
15 plus C minus Y2?
18.
Y2.
18.
Y2 is 18.
18. Plus, what
correct.
about f of 3? It's C, right? And what
Yes,
is the
sir.
value of y3?
4.
4. What about f of 4? Whole square. What about f of 4?
C minus 3.
C minus 3. Okay. And
C,
y4?
it's C minus 27, na, Shad? Could you please check again that? F of 4 is C minus
Yeah,
27.
minus 27 plus C and minus 24. Okay.
C
It's
minus
minus
27.
27 and minus 24 to minus plus 24. Okay.
Yeah.
Whole square. I think C
C
calculated the thing.
plus C also, sir, inside.
Plus C. C is there, no?
Okay, yeah, got it.
C
-3.
-3 whole square. This thing I need to calculate. Okay. So basically, if you are able to see, if I will solve all those things, I will solve all those things. This is basically 2 times C -4 whole square. Did you check this y3 value is 4? Yeah, fine.
So
2
why
times
is
because
so the
this one
first
times and this
first
two,
molon
this 2 times.
part of that function? So
Okay.
let's see as you see.
Now, what is 15 minus 18?
-3.
-3. C -3 whole square. 2 times, na? This one is C -3 also.
Yes.
3 times. Basically, this will also become C -3. So 3 times C -3 whole square. Right?
Yes.
Understood up to this? What I have done here? I am solving this thing only.
Yes, sir.
Now 2 times. This is what? C square plus 16 minus
8.
8C. This is what? 3 times C square plus 27 minus 3 to the 6C. Right? Now, here 2C square plus 3C square is what? 5C square. Okay. Now 16 to the 32.
No, but in the second bracket it should be 9. 3 3s are 9, not 27.
Okay. Okay, it's 9. Okay, 9 3s are 27. 27 plus 32. How it will be? 27 plus 32. 7 2 is 9 5 59.
Sir, can you
Minus.
please share this PDF?
-34C, sir.
Yeah, I will say, don't worry.
Yes, sir.
Okay, what it will be? 2 8 8 to the minus 16 and
18 -18. 6, yes, sir.
Can't open my mic. Everyone is sleeping.
Yes, sir.
Sorry.
Yes, sir.
Can't
-34C
open.
हो जाएगा.
Minus 30.
4C.
34.
Okay. This function, this is looking like this. Okay. So what is my question? The question is like, at what value of C the function, like that function will be the best fit value. It means that the error, this is the error, right?
Minimum is, sir. Okay, sir.
Yeah, this error will be minimum.
Slope,
So
sir.
this is the quadratic function. You know at what value you can get minimum. C is equals to minus B by 2A.
Yes, sir.
So what it will be? Minus times minus 34. B value of B is minus 34 by
Value
2A.
of
2
B
into
is
5.
10, sir.
This C coefficient, na, this is looking like 5x
okay,
square
I got
minus 34x plus 15.
Yes,
So
sir.
this will be your answer.
3.4, yes.
3.4, yes, sir.
Got the point? How we have to solve the question of sum squared error?
Sir.
Yes, sir.
So basically, in that question, okay, someone is saying can't open my mic. Everyone is sleeping.
No, he wanted to say that in his room, his parents and all are sleeping, so he cannot speak.
Actually, he wanted to ask a question and he cannot like open his mic and ask.
Okay. Which question? Which
made a
question?
question.
Okay. I am saying in the class everyone is sleeping.
No, sir. No, sir. No.
No, sir, he also
Continue
check the
after
question
this,
if you want, if you can
do
check.
this.
Okay. Okay, I am taking this question. Okay, sum squared thing you have like idea. I think you got the idea how we will solve the question. I will explain what is this. So this is the question. Are you able to see?
Yes, sir.
Presented by Aman Sahu. Okay. What's the time?
Sir,
11:53.
sir, I have
We
a
will
doubt.
wrap up by 12. Yes.
So sometimes this SSC formula is written as sigma yi minus mx minus c.
Sorry. See, that will be formed if fx is equal to your line. Okay. If your function is given by linear form, then we will apply that formula because your function is given by linear form. Now here function is given by polynomial form. Okay.
Yeah, if the function given is linear, then also we can
Then you
use this
can,
formula.
yeah, because
Y
you have to
minus
put the
m.
value of f of x only, no?
Okay. That means both of them are the same. Both
Yes.
of methods are same.
Yes. Okay, so this question is showing Sonia and Hena want to solve a quadratic equation. Yeah, this is a nice question. I think this question is asked in the previous year. This is a previous year question, like, right? Yeah, I can't say, but yeah, it's looking like a previous year question. I have heard this question. I have read
Yes,
this
sir.
question. Sonia made a mistake in writing down the constant term and end up with in roots. Okay, I will explain this question. Okay, this is a nice one actually.
Yes, sir. It's a previous year, sir. Yeah.
Yeah, this is not, see this that kind of, this is not so difficult. Okay, so what is the question? Sonia and Hena, two are best friends, and they want to solve a quadratic equation. Sonia made a mistake in writing down a constant term. Okay, constant term. Constant term is mean if a equation is written given by this bx plus c, then she made a mistake in this c. Okay, equal to 0. She made in place of c, she made this c d, and got the root x is equals to 3 and 4. Okay, these are the root of this equation. Okay, there was suppose this is your original equation, ax square plus bx plus c. This is your original equation. Okay, this is your original equation, is equals to 0. Now, what Sonia made mistake? Sonia mistake in the constant term. So, suppose we consider this equation, ax square plus bx plus d is equals to 0, and got the root 3 and 4. So, you know na, if 3 and 4 are the root, then the equation will be given by what? A times x minus 3, x minus 4.
X square minus 7x plus 12.
Right? The equation will be look like this, no?
Yes, sir.
Yes, sir.
Right? So basically what it will be? It will be what? Rather than writing this, I can write like that now. Is equals to a times x minus 3, x minus 4, right?
Yeah.
I will solve this. Okay. Now read the another question. Further question. Hannah made a mistake in writing down the coefficient of x and got the root this. It means that she wrote this b as suppose some b bar and all. So she wrote like this, ax square plus what I will take? C,
Any value,
D, R, suppose
any
B1,
value, right? V1, okay.
x plus the constant term is same, C is equals to, and got the root 2 and 3. So a times x minus 2, x minus 3. Okay, now consider the leading coefficient is 1 for all the cases. It means that you have given the value of a as well. Okay, you have given the value of a. So this is x square. Now it's fine. The value of a is given. It's 1.
Yeah.
Okay. Consider the leading coefficient. It means the coefficient of leading order term. It's 1 in all cases. The correct root of the equation you need to find. So basically what you need to find? You need to find the value of b and c. Simple. So how will you find? Just multiply this. What it will be? The first equation will be x square plus bx plus d is equals to x square minus 7x plus
12.
12.
Yes, sir.
And the another one is x square plus b1x plus c is equals to x square minus 5x plus 6, right? Right?
Yeah.
Up to this, everything is clear?
Yes, sir.
Now, you have the value of b, which is minus 7. You have the value of c, which is 6. So what is your original equation? You need the value of b and c, no? You got the value of b and c?
Yes,
So
sir.
what is your original equation? X square minus 7x plus 6 is equals to 0. Now you will be able to find the roots.
6 and 1 हो जाएंगे sir. Yeah.
Yes.
Yes, sir.
Okay. Got the point? See, this question is looking like very tough, but it's not tough, right?
Yes, sir. The language is only tough.
This is just the language. Question is looking like, yeah, it's a very tough question, but it's not tough. It's actually easy question. Okay, let's move to the sum squared error.
Sir, what
Basically,
answer
what
that
is it?
for that question?
Sorry?
What was the
This
answer
question.
for that question? For
6
PVC,
and 1.
I don't know the answer right now. If I need to solve this
1 and
quadratic
6
equation.
will be.
Yeah, 1 and 6 will be the answer. So what is he asking? The correct roots of the equations are 1 and 6. Do we get to carry a calculator in the exam? No, you don't need to carry the calculator. They will provide a calculator in the exam itself. What kind of calculator it will be? There will be some small pockets from here or somewhere here. Okay. There you need to click. The calculator will be open like this.
Okay, sir. So
Does my
like they will not
calculator is
allow
visible to
the
all?
scientific calculator.
Sorry?
They will not allow scientific calculator.
No. The calculator will be on the display in the display only.
So they
Okay, sir.
mentioned it will be a scientific calculator, the ones that they will give online.
Yeah.
Just a minute, okay. The calculator will be open like this in that corner or in that corner. There will be a sign for calculator, this kind of sign. Okay, you need to open the calculator like this. Okay, now for that, if you want to calculate something, you have to tap like this.
Okay, sir.
Okay, now calculate the calculator will not be looking like this. See, there is a app named as Gate Calculator. Just download it. You will find and try to practice on it. See, in the calculator thing will be used on the sum squared thing only in the math one. Okay.
Yes, sir.
It will be used in stats, sir, a lot.
Yeah, it will be used stats a lot. In the stat part, because this sum squared thing is also coming from the stats only.
Oh, sir.
I think this thing is done, no?
Sir, you can send both the PDF and I sent you a question. Please check it.
Yeah.
Yeah.
This is an example. A line y fit. What does it means by best fit value? The best fit value is what? Means that we need to find a function for that this error will be minimum. Okay. The sum squared error will be minimum. So for that I have tried to something, but they will not going to ask find the function which is best fit for the given data. They will not going to ask because finding the function is very difficult. They will give you the function. They will say, yeah, this is the best fit function. Find the sum squared error. Or the question will be like that only. For what value of C, A, B, the function will be the best value. Best fit value. Got the idea?
Sir, what if the SSC is 0? What does it mean?
If SSE is 0, it means that the whatever the function you are taking, that is the exact function. That is the very accurate function. Okay. You can
Means there is
believe.
no error.
Yeah. There is no error. The error
Then
is 0.
we can say it is the best fit.
Yeah. Best to best fit, you can say.
Sir, I sent you a question. Please check once.
Yes. Just a minute. I will send you the link. Okay. Please.
No, sir, this is mine.
Just a minute.
Can you just explain the language of this?
Okay. Can you please try to open this link? Does the thing is visible to all of you? Like the slide is visible to all of you. What language?
Such a question I sent. Sanskar. My name is Sanskar.
Yes. Just a minute. I have sent the link of the PDF. Okay.
Okay, sir.
Just check it once. Accessible,
It is
right?
Yes, sir.
sir, it is.
Okay. Now these are the field for week 1,
Sir, I
2.
sent the second last one is mine one. Just check once.
This one, na? This
Not
one
this one,
is
not
what?
this one, not this one. The previous. Wait, I will
Okay.
just repost it again.
Bhargav?
Sir, can you
Can we
please share
able to
Yeah,
use
the
this one,
PT?
this one on the screen?
One by one. Okay, let's see this question. What is this? Let P be the intersection point of this line. You have two lines.
Yes, sir.
You have two lines, this one and this
sir, I
one.
sent you.
Yeah, just a minute. You have two lines, this one and this one. Let L be the straight line passes through the point P, this point. Firstly, you need to find the intersection of these two lines. And now you have the idea that this line L is passing through the point P. Now, if you want to find this line, you need one more information only. Either that will be the slope and whatever it will be. Here is the given. And the y-intercept of the polynomial Px is equals to this. What does it mean? Yeah, I think he is missing something. And the y-intercept. Okay, here they missed something. Like, and the y-intercept of the L is exactly same as the polynomial of this kind of thing they want to ask. I think there is something missing.
Yes, sir.
I think, and the
Sir, I have posted the
y-intercept
full
of the
question, sir.
polynomial.
It
Yes.
was actually in September attempt, so
I have posted the full question, sir. You can check that.
Where? What's your name?
Asif.
Sir.
This question only.
Yeah, but it's a full complete along with the answer.
Y-intercept of the polynomial Px is equals to this.
So it's simply saying that we have two equation, दोनों points का जो intersection है वो point B है.
Yeah, I think
Point
he is asking
Px,
for y-intercept, like the
yeah,
y-intercept of the L is given by this Px.
yeah, P of 0, that is 1, 0, 1.
Yes,
So
1.
we have two
Okay,
points,
so
that is P and 0, 1.
yes. So find the value. Okay, he is saying, see, the language is not clear. I am also saying the language is not clear, but yeah, still, I think he is asking for that only.
yes, sir.
Okay. So y-intercept, you have the y-intercept, which is 1. You have the intersection point. Now you have the y-intercept and you have 1 point. You can easily find the value. Like you can easily find the line equation of line.
Yes, sir.
Now, what is the question? You have the table. The question is based on the above data, answer the given sub question.
Yes.
He is asking for slope, and sometimes he will ask what will be the sum squared error. So that thing you can do now, that calculation by this formula.
Okay, sir.
Okay, f of xi minus yi whole square. Okay, Bhargav, let's take the Bhargav's question.
Yeah.
Okay, others, if you don't have doubt, you can leave the class.
Sir, you have to
please
also
send the
send the
PDF.
personal notes also.
Yeah, I will send it.
You just send one of the links.
Links is please copy that link.
Yeah, copy it, but send your personal notes. That is more important.
Yeah, I will send. I don't think so. Even after this class, if I will see that notes, I will not be able to understand anything. I don't know how will you
Sir,
understand.
can you please send that PDF?
Yeah, I will send. Just a minute.
When?
Okay, let me send first. Okay.
So, and also the recording of the previous year question that was solved today morning.
Yeah, that I will then tell them. Okay. 23.
So how important are the solve with us questions for quiz?
It's just for practice. I am suggesting that one because there I have discussed like for in the my session, I'm thinking I have taken only one solve with the session. So in the my section, I have discussed about the sum squared error in a very deep way.
Okay, sir.
Sir, I have
So
a
that is
doubt.
why I was suggesting.
Yeah, I have a doubt from function, like onto function. I have a doubt in one question. Is it okay if I send it on chat?
Yes, you can send.
Yeah, I have sent it on chat just now.
I have sent that link. Okay, like that notes. Oh, let's take the Bhargav doubts. He is waiting for some. Now, two buildings A and B are shown in the below diagrams. This is the building. This is the building. So I think he is asking for maximum height. What it will be. I think this kind of question is already discussed in one of the classes. A woman walks. Okay. A woman walks out of the building B to get some sunshine. Okay. She is going like this way. According to the situation given below, assume the right direction of building as positive direction. Means that this direction positive, and ground as x-axis. It means that this axis is x-axis, and the first sun ray not blocked by the building. Okay. B has a slope -3. Okay, what is saying? First sun ray not blocked. Okay, this line. The very first ray which is not blocked by this building B has the slope -3. It means that the slope of this line is -3. Okay, what is the further question? Consider the board building. What is the further question?
Yeah, wait a second.
Just consider this point as 0, 0. Okay. Now, from if this is 0,
this is the
point will
complete
become
question.
Sorry?
I was saying that this is the complete question.
This is just the half of the question.
Sir, I think we have to choose based on the options.
It's a numerical type, not of. There is no options.
Okay, just send the further question. I'm waiting.
Sir, meanwhile, somebody else posted another question. Could you
Yeah,
please,
I will take
explain
that question. Asif or
I just copied, sir.
Yes, sir. The one which
I sent you.
Which question are you
Oh,
talking?
sorry, it's not.
Bhargav sent that. Let's take that one. He was waiting for some time.
Okay.
See. Nothing is there. Numeric thing. Enter your answer nearest to the integer.
It is asking
What is the question?
How much distance she has to walk. It is in the first part itself.
Where? Assume the right direction as this.
How much minimum distance in meters? Second.
Where?
Second line.
Okay. How much minimum distance in meters will she have to walk to the right of the building B according to the situation given below? It means that you need to find this distance, right?
Yes.
It's easy, no? Consider this point as 0, 0. Okay.
Yeah.
Then this is 25 meters, so this point will be 25, 0. Okay. Now, here you can see if this is your equation of line fx, suppose.
Yeah.
Okay. Then your f of 25 is what? 60. Because this touches the line. This line, this slope.
Yeah, okay.
See. Right? So this point, you got this point, which is what? 25 and 60.
Yeah.
Right? You have the slope of the line, you have 1 point.
Yeah.
You can find the equation of line.
Okay.
Once you got the equation of line, you will get this point.
Got it.
X-intercept.
Okay.
Now, 2 points are there. You can use the distance formula.
Okay.
Okay. Okay. Okay. Asif's out, right? Yeah, Asif, this one is remaining, right?
Yes, sir.
Sir, my question from functions. Yeah,
Yeah,
this.
just a minute. I will take the one by one.
Yeah, I also have doubt in this one also.
What's the doubt here?
Sir, how to solve this though?
Yeah, like how to approach this, like
Yeah.
really for functions.
What is the question? Let S be the set. Everyone is able to see the question, right?
Yeah.
Yes, sir.
Okay. Let S be the set of all quadratic function. Okay, all quadratic function, whatever it is. Define two relation R1 and R2 on the set S. Defined as like R1 and R2 defined S to S as follows. R1 is two elements of the set S said to be related if they have same axis of symmetry. Same axis of symmetry, it means axis of symmetry is given by minus b by 2a. This line is your axis of symmetry, right?
Yes, sir.
It means
Yes,
that two equations, like how to say, yeah, we will say in this relation two equation of related, like two quadratic equation of related to each other if this equation, this minus b by 2a value will be same for both. Okay.
Both
Your
the x
equation
and
is
y
given by
coordinates, sir.
this. Sorry.
Both the x and y coordinates are same, sir.
X and y coordinate? No.
This is
Suppose
the
you
x
have two
coordinate of axis
equations.
of symmetry, right?
Axis of symmetry is what? So this is, if this is your equation, quadratic equation, then
Vertex,
this
yeah.
equation, yeah, graph of quadratic equation, then this line will become your axis of symmetry, right?
Okay.
Because after
So,
this,
sorry,
if you will
sir.
put mirror
I
here,
was thinking as vertex. Sorry, sir.
no. That is why I was using the terminology the line of symmetric.
Okay, thank you.
Okay. Now, if you have two equations, like if you have two equation a1 x square plus b1 x plus c, and similarly you have a2 x square, why not writing a2 x square plus b2 x plus c2, then it is saying minus b1 by 2a is equals to minus b2 by 2 a1 2a1 2a2. So this is basically what it is saying. It is saying b1 by a1 is same as b2 by a2. If two equations are related to each other by the R1 case, then this thing has to be equal. Okay. Then
But
another, yes.
does this mean that it signifies the points on this parabola that are equidistant from the axis of symmetry, that R1?
Sorry, I'm not able
Does
to
R1,
understand.
the relation R1 signifies the pairings of points that are equidistant from the axis of symmetry are on the parabola S?
Yeah, you can say like that. Yeah. So R1 you understood, right? What is R1 basically? If you have two equation, then this ratio will be equal to each other. Okay, b1 by a1 equal to b2 by a2. You got this point up to this?
Yes, sir.
Okay, what is the question? R1 is a reflexive relation or not? It's reflexive, right? If you have a equation ax plus b, ax square plus bx plus c, reflexive is what each equation is related to each other or not. So b by a equal to b by a now. This thing always happen. So this is reflexive, right? Because each equation has same like if you fix the equation, quadratic equation, it has it always have the same as axis of symmetry, right?
So could you say that
Right?
again?
Equation is same only. This equation is same. Basically here a1 is a1 b1 c1 is equals to a b c, and here also a1 is equals to a2, b1 is equals to b2, c1 is equals to c2. Only one equations are there. Same equations are there. For reflexive we will say na this a value are there or not. right? For that equation will be same, and then we will say, yeah, for one equation, this relation is satisfying or not. So if you have a equation like one equation only, so basically what I am.
Sir, they did not
What
say
I
C1 equal to C2.
No, not C1 equal to C2. What I am saying, for reflexivity, how will you check? For all A belongs to R, sorry, A belongs to capital A, this A pair should be inside this R, no? It means that for this second and first, like for this first one and this second one, both thing will be same. It means that this equation, the first equation and second equation has to be same. It means that A1, A2, A1, A2, B1, B2, C1, C2, these are equal. A1 equal to A2, B1 equal to B2, C1 equal to C2, right?
Yes.
Right? If you will consider both equation in this term, like same, so that thing will be equal. So in this case, this B1 by A1 is same as B2 by A2, na?
Sir, C1 and C2 may be different, right?
If you are
here
taking only
considering-
one equation, if you are taking only one equation in this place and this place as well, so C1 and C2 this should be equal, no?
Oh, sir, there may be another equation.
Yeah, but in R, right?
The same
how we know that
axis
we
of
have A
symmetry.
and A? Like
See.
here, A is basically the function, right?
What I am saying, you are not getting that point basically. Okay, what I am saying, I am trying to say, what I am trying to say basically, you have a relation. Okay, you need to check this relation is reflexive or not. This is your set A, set of all quadratic function. Now, how will you check basically? You need to check now this A inside R or not for all A belongs to A, right? Right, this is the thing, no?
We can't see your screen if you are.
Right? You need to check this. Right?
The screen is not visible.
Oh, okay, sorry. Now it's clear?
Yes, sir. Yes.
Yes, sir.
For all A belongs to A, this A has to be inside S. Now, this A is what? This is set of all quadratic function, like this AX is equal AX square plus BX plus C. Right? Where A, B, C are coming, like A is not equal to C. Whatever the assumption is for quadratic equation, it is there. Okay. Now you need to check this is reflexive or not. What you need to check? You need to check for each, element of this form, this thing is happening or not. It means that AX square plus BX plus C and AX square plus BX plus C. It is inside R or not?
Yes.
Right? So basically for not this R, this like the smaller
Relation
R.
R.
Yeah, relation R. So basically for being inside this R, your B by A has to be equal to B by A, but it is also equal. It is always equal, right?
Right.
Because equation is same. It is not changing.
Yes, yes.
Right? So this is reflexive, right? No issue.
Yes, got it, sir.
Okay, makes sense. Yeah.
Right? No issue, na?
Yes, sir. Got it.
Equation is same. Okay. What is the further one? Where is the question? I missed that. No, this is what. R2 is symmetric. Okay, so let us discuss about R1
So, but
itself, and then we will
sir,
discuss.
sir, please hello.
Yes.
So,
Yes,
but here A1 and here it is A1 and the second equation is A2.
E1 and E2, what does it mean? This one and this one.
Yeah.
They are saying, right?
But the thing is, we are checking for AA now. We are not checking for other thing.
Okay, sir. Now got it.
For reflexive relation is what? This A has to be inside this. It means that the first place and second place, like both are same. if this first entry is, suppose this is a chair, and in both chair only like the same person will is going to sit.
Okay.
Okay, we are not as like allowing to sit another person for reflexivity.
Okay. Okay. Got it.
Okay, suppose this is one place where Pradhan Mantri will come. This is another place where Pradhan Mantri will come. So there is a specifying chair where Pradhan Mantri only Pradhan Mantri will can sit. Okay, only Prime Minister can sit. So for that, but Prime Minister is only one. So he is only the person who can sit this in this chair, right?
Yeah. So basically, we
So
are trying to say,
that's what I am trying to say.
yes, sir. So basically, you're trying to say is that if ax square plus
Same.
bx plus c and the same is inside R, then it should satisfy the condition of the relation, which says the
Exactly, and it is satisfying because all the
yeah.
components are equal to each other.
Yeah, got it, got
Oh,
it.
got
Actual
it.
symmetry is
Got it.
becoming same. That's why.
Exactly. It is is it symmetric? Yes.
Yes.
Yes, yes, yes.
Yes, sir. Right, because like if you will take different, so it is symmetric. So you
Because
understood now how to solve this?
every quadratic equation will be related to itself.
Yes.
Yes.
You know now how to solve this kind of question?
Yeah.
Now we know.
Yes, sir.
What's the time? It's 12:26. Okay, can we close the session now? Actually, I am tired. I am speaking from like how many hours?
Yes,
4
sir.
and 4:30 I guess.
Sir, I have a small doubt.
Okay. What's your name?
Sir,
What's your name? What's your name?
Okay,
Like I have to check now.
Kiran.
Kiran, did you send that doubt?
I actually sent a question a long time ago regarding functions. So if it is possible, you
I'm
can
checking.
check it.
Kiran, right?
No,
No, sir.
Got you.
No, sir.
So the E equals to 1, 2, 3, 4, and F equals to the one which asks number of onto functions.
Where I'm not able to. Can you send it again?
Yes, I'm sending it right now.
Yeah.
Sir, in
Kiran,
the
what about you?
meanwhile, I have a doubt that if a graph of a polynomial is given, then can we find the peak points? This was given in the previous
Yeah, we
question.
can. If you have the graph, you can easily find, no?
How?
Okay. Just if you have
And we
the
are
graph
given
like this,
just points only, not the function.
not function. Now this
Yeah,
functional value,
not
you are talking about. How will you find this functional value? You are not.
sir.
You can say
Only
yeah, peak will be given by this point. You cannot say what will be the peak.
so it is not a quadratic polynomial. It
What
is
is it?
a
In general function.
um,
Giving
degree
like this.
more than 4.
More than 4. Polynomial function degree more than 4.
Yeah. So and the polynomial is also not given. Only few points of x-intercepts are given. Then how to find peak points?
Then it is
2
impossible, right?
points of x.
It
If
is
function is not given, you see you can say at this point the function value take the peak. But if the function is not clear, it's very difficult to find the peak point. If you have the question like this, please send it here so that I can understand. I can properly understand your doubt.
Sir, this question was asked in previous year terms.
Do you
Wherein
have that question right
Andrew,
now?
sir, I don't have the question. I will share it.
Okay, please share it. Okay, let's take this doubt.
Because this is the last question that I have doubt in from all the
Okay,
viewers.
this one now. This one now.
Yes, sir.
Okay. E is the set and F is another set. Okay. find out the number of onto function. Okay, this is also an important one. How will this that number of onto function? Okay, how many functions you can make for onto function? See this value. This one. How many value this? You know the both function has to take one value.
Yes,
Right?
sir.
So how many value this function can take from here? How many possibilities are there for this one?
It's 4.
4.
Your a function is defined from E to F, and for F you have value 1 and 2. So for this one, how many values are there?
4.
4.
4. Okay. Now what about this 2? How many values are there?
4.
4.
No.
So what?
Because once you assign a number from this one, that number cannot map to this 2, na? Otherwise it won't be a function.
Yes, sir.
So
Okay.
there will be only 3 possibilities. So what is the answer? 12.
So answer is 14 given.
14 given. Okay. Asking for surjective function, no? How it will be 14?
It cannot. I also thought for 14 first, but at most means one outgoing edge should be there from each domain points. So
Yes.
So how did you multiply there, by the way?
I am taking the combination. It's just like this. Suppose I have 3 t-shirts. Okay. Black one, white one, and then yellow
We
one.
can't see the
And
screen.
I have 2 pants. 2 pants. What are those pants? Suppose black one and white one. How many combination I can take? One day I will wear this black. Then one day I will wear this white, black. Then one day I will wear this. Just a minute, okay.
So we can't see the screen.
It's in the stat 5th week. Stats 1 from 5th week. It's a simple permutation and combination and uh, multiplication principle that we see. That
So
if
this
we have
question is not from week 1.
Question might be, it's just a simple means if anyone has studied basic probability, na, then it's just basic counting principle.
Yeah, exactly. So how many combination will be there? There will be 12 combination. Sorry. This for this this each person, for this each person, there will be 2 combination, right?
Yeah,
I've done myself.
we have 2 placeholders.
Yes. So for each person, we have 2 values. So there are how many values are there? For this, we have 2 values. For this, we have 2 values. For this, we have 2 values. How many values are there? How many possibilities are there? 2 plus 2 plus 2. It's 3 into 2,
So
which
your
is 6.
screen is not visible.
Sir, your screen is not visible.
My screen is not visible. Now it's visible.
No, sir.
Now it's visible.
Yeah.
Yeah.
So basically you have this one B1 BWY, matlab black pant, white pant, and yellow pant, and you have white shirt and yellow shirt. How many combinations are there? For one B, you have 2 combination. For this white person, you have 2 combination. Like for this B, you can wear this white one, and or you can wear this yellow one. For this white pant, you can wear either this white shirt or a yellow shirt. For this yellow one as well, you have 2 combinations. How many combinations are there? 2 plus 2 plus 2, which is 3 into 2, which is 6.
6.
Similarly, but the thing is, here you have 4 elements, 1, 2, 3, 4, and here you have 2 elements, only 1 and 2. Now you need to find how many surjections are there. So you have to remember that. For you have to like you have to apply the constraint. What is the constraint for function? Like here, one value cannot map 2 value, right? One cannot map 1 and 2 simultaneously, right? So if I will take this one here, so how many possibility, like how many possibility in this set for this one?
Two,
One,
sir.
two,
4,
three,
na?
four.
This 1
Right.
can map 1, 2 can map 1, 3 can map 1, 4 can map 1. So there are 4 possibility, right? Now, what about this 2?
For 2 also
There are
4.
only 3 possibility, right? Why 3? Because once you assign a possibility for this number 1, that number, suppose you have assigned this 1 for this one. Now this 1 cannot participate, right?
With the selected
It cannot
number.
participate with mapping with 2, right?
Yes, sir.
Right? Because it's after that it will not become a function itself. So this will not. So how many possibilities are there? Only 3.
Got it, sir. Yes, sir.
So how many combinations are there? Like in this case, you have 4 pant, 3 t-shirts. How many combinations are there?
12. Okay.
Okay, there will be 4 into 12. 3, 12.
Okay.
Shall I close the session now?
Sir, can you resend your handwritten notes one time?
Again.
Yeah, just last time, please.
So, you discussed one
I think
question, like
you have
the
not
subset
shared
one.
the handwritten slides. So can you please?
Sorry, I have shared the handwritten slide, right?
Yeah, you have sent, but just send it once again.
And sir, if
I
you can
think I have explained this thing in the another. Where is it? Where I have this is the SSC part, right?
This is the one.
This is the SSC part, but where I have explained this black white thing.
Zoom out, right? Zoom out and see.
Here is no. I think some other site. There is so many slides now, so many classes are there. So many things are there. Which slide is going? I think that is erased. This is the different one.
Sir, in the last example that you explained, every function would have a pre-image, then it is surjective, right?
No. Every surjective means what? What are the codomain you have? What are the codomain you have?
Codomain
Like
equal
this
to
is your
range.
yeah, codomain has to be equal to range. What does it mean? It means that whatever the value are inside this set, it has pre-image. It has pre-image, no?
Yes.
It has some pre-image. That's what I'm saying. So
Like for surjective function, f of x1 can be equal to f of x2, right? That
yeah,
condition would
can be equal
satisfy.
to that could like surjective function can look like this as well. Like this kind of in that example it's
So your voice is not audible.
one function cannot possible, like
Yeah.
right? So
in that counting that we did, right? So are we considering like the possibility of 1, 2?
all the possibilities we are considering, what kind of function we can make, all the possibilities we have considered.
But sir, why are you considering the ones where like the reverse is also being taken into consideration, like 1, 2 and then 2, 1?
Well, I am not taking like that. I am just saying for this one, how many possibilities are there? For this two, how many possibilities are there? And then I am multiplying. I am not arranging this 1 and 2. What? I am checking the combination.
Okay. Makes sense. Okay, got it.
Okay, I am checking the combination. I am not checking that thing like that permutation thing. I am just checking the combination. Okay.
Thank you.
Shall I close the session now?
Yeah, you can close, but just send the notes once.
Just a small doubt, a pinpoint doubt. In one of the
Yes.
question of that subset, that a relation was defined from A comma B, where the collection of A is a subset of B.
Sorry,
In that,
can you repeat it?
in one of the questions where a relation, like I'm reposting it, so in
Yeah.
this
I
question,
feel like
I didn't
Yes. Yeah,
exactly
you
get
just post
the
that.
first part. Rest
You
I
just
get.
post that.
In
You just
Okay.
post
also,
that.
we're
We will
gonna have a
discuss.
PYQ
Okay.
session. You can ask there also.
Yeah, you can ask. Okay, I feel like there is something missing in the question. Which question are you?
So I have posted like it's last I have posted by the name of Ankit itself.
Okay, this one.
No, sir.
A is a subset of B. That question is already
Yeah.
discussed, right?
That one. On that question, the reflexive part, like I didn't exactly get. Rest I got. Like it's transitive.
Okay.
Why
So
it's
basically
anti-symmetric.
every set, so see, basically every set A is a subset of itself, right?
Yeah.
So reflexibility is already automatically hold, no?
It holds, but if we particular take a set, like uh, if we take a set, let's say A is 1, 2, and B is 1, 2, 3,
Then
then our relation which says like how we are rating this A comma B.
A comma B is what? A is a subset of B. The relation is defined like that. A is a subset of B, right? Here, see, A is a subset of B, means that this pair is allowing to inside R.
Yeah.
Now, I need to check whether AA is inside R or not, right?
Yeah.
This is the reflexivity, no? This is the reflexivity. It means that A is a subset of A or not. That's what I need to check. But this is the trivial thing. This thing is
Yeah,
always happen.
this is trivial thing. Yeah. Okay.
Yeah. So what's your doubt? I am not getting your doubt. That's the
Oh,
thing.
but actually, if I wanted to write this set, the R, using this A and B, how can I write it?
So
That
it is
was my
simply
doubt.
write it like this only. This AB pair such that this A is a subset of B. Simple.
Okay,
Simple.
no, we cannot write more than that.
Yeah, we cannot write more
Okay.
than that.
Okay. Thanks, sir.
Because it's very difficult. If you, it depends what is your power set basically. Because you cannot say take set of all the set, because set of all the set is just a paradox, not a
Yeah.
set. Set.
Yeah.
So we cannot
But
say.
of also
For
all
that you have
possible
to
elements
define
of
a set
set.
S, and for this set S you have to define a power set S, and then you can apply this relation in that power set.
Okay, got it. Thanks.
Sir, here it is anti-symmetric also, right? This one.
That we need to check. It is anti-symmetric.
Yeah, it's
Because of
anti-symmetric.
This one, this one.
Yeah, this is
Yeah, it's
anti-symmetric.
anti-symmetric.
Yeah,
Because if
yeah, this is
A cannot be a
anti-symmetric.
superset of B always. For a
Yes.
given example also you can see. So it's anti-symmetric.
Okay. Ayush, you are Ayush, right? Ayush is saying, I feel this, I feel like there is something missing in the question. Which question are you talking about, Ayush? I'm not getting.
Sir, you can just go scroll up to the chat and just resend it.
Ayush Dattawala.
Sir.
Which one? Which one is the question? Can you please resend it? Others, you can leave the session. How many
Yes,
people
sir.
are
You can just
registered?
resend the file. Just scroll up the chat and please resend. I just my internet connection was weak, so I just
Okay,
rejoined again. That's why I can't see the chat now. Don't resend now. Just you can just scroll up the chat and see. Just resend that one.
This one, I guess. No, this one is not. And this one, new session.
You sent the file right in the meeting chat.
Yeah.
I was just resend that.
From where it is reside. No, I have to just upload like that.
Yeah, you have to upload.
It's going very slow because network connection is weak. Someone please upload this, like send it from your side because my network connection is weak right now.
Yeah, can anyone resend it? The file?
Anyone please? Ayush, what is your doubt basically? I am talking about the one we are attempting. Like I am about the E to F question. Okay, why we are going with F to E, right? Because we are discussing about surjectivity, and for surjectivity we have to check whether these two element, this is for visible or not, this slide. See, in this F element, what is the restriction in the surjectivity thing? The restriction is each element of F has a pre-image, right? One there will be some element in E.
Your screen is
For
not
that,
visible.
sorry. Sorry.
Your screen is not visible.
My
Your
screen
screen
is
is not.
visible, right? Now it's visible.
Sir, yeah, sir, you are visible.
Yes.
Sir,
So
you have
what
discussed this
is?
question.
Yeah, we have discussed, but he has some doubt. Okay, so what is that? Hey, please send the slides. Please send the slides.
Not the slides, the handwritten
Actually,
notes.
my network connection is too slow, so slide is like going in a very slow manner. I don't know. It will take around billions of years, I guess. Okay,
Yeah,
so
got it. Thanks.
what? Okay, fine.
Thanks, Abhishek.
Yeah. So why we are going with F2E? Because see, we need to check the surjectivity. For that, we need to check. See, this suppose this F is nothing but a set of two students. Now we need to check each student is getting chocolate or not. I have 4 chocolate and at 2 student. I need to distribute the chocolate as each student get at least 1 chocolate. Okay. 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 Ayush? Please answer. Okay. So for one student, how many chocolates are there? We are going to student Vaisra.
Yes, sir.
What is my condition? We have 2 students and 4 chocolate. And the condition that is that each student at least each student will get at least 1 chocolate. Okay, we have 2 students, 4 chocolate. At least each student get at least 1 chocolate. So for one student, suppose I am taking the first student. Now for first student, how many chocolates are there? 4 chocolates, right?
Yes.
4 chocolates. Now
Yes, sir.
once I have given the chocolate. Now I have assigned a chocolate for A. How many chocolates are remaining? 3 chocolates, right? Right?
Yes, sir.
Right. So how many possibilities are there for second student? Only 3, na? Because 1 chocolate is already booked by player 1 or student 1.
Yes, sir.
Right. So how many total combinations are there here? 4 into 3, right?
12.
So total 12 combination. Now
Yes.
got it?
Yeah.
Sir, here one small doubt. Here, find out the number of onto functions from E to F. So
Function from E to F, but we have constraint on F now for onto or for surjectivity.
okay.
We have constraint on F, not E.
But from E to F, okay.
Function is
For
defined
F,
from E to F, but constraint is on F.
okay.
Okay, not E. The constraint on E is just saying one one chocolate cannot be distributed as both the student. Like the first chocolate cannot each chocolate cannot be distributed in the two parts. It's just not like chal bhai आधी आधी कर लेते. Not like that. Okay.
Right.
So that kind of constraint is there. That is why we are taking for first one we have 4 choices. The another one we have only 3 choices. Got it?
Right.
Okay. Okay. So I am closing the session now. Good night,
Sir,
guys,
sir,
and
I
all the
have a
best.
sir, I have a question.
Yes, yes, Abhis. What's your
Sir,
name?
in my area, my internet was shut down due
Okay.
to some electricity problem.
Okay.
So for that reason, I was not able to submit the mock test.
Okay.
So what can I do?
Mock test. Mock
Yes.
test or graded assignment?
No, I submitted grade assignment because the internet problem was today.
Okay.
So I did not submit the mock test.
Mock test is not like that. See, the mock test is not graded, I guess. The numbers are not assigned for that. Why are you worried about it?
It's got a bonus marks, right?
It's just a mock test for your practice purpose only.
Okay, it is
There
not
is no bonus marks on mock test, right?
I
If I am
think there
not
is,
wrong.
sir. I think there
So
is.
for
Few of them
for
are
PT,
graded.
for CT, there is a
Okay, if
graded.
there is some okay, if there is something like that, please, I'm again saying you, please mail about that. Okay,
okay.
mail to the IITM support. Okay, mail
Okay.
regarding that. Okay,
Okay.
and please raise this concern in tomorrow's 7 o'clock session.
Okay, sir.
Okay, I think Vishal sir can do something.
Sir, I am not able to download this OneNote link file that you shared in
You
the
are not
chat.
able to download.
Yeah, it's like restarting and but could you share the link, only the link for the notepad? Like there's a share option. I think it might be possible.
I don't think so. There
I
is
don't know,
some
but I'm
share
not able
option.
to download it. I don't know if anyone else is able to.
Share the entire notebook,
I
that kind
have
of
PDF
thing.
of it.
Yes, if
You
someone
just
has PDF of it, please share.
yeah, you just share your mail ID. I will forward it to you. I'm
Just
trying to paste it over here, but it's not working. Showing some error.
Yeah, just paste your email ID here.
Can you send me
done.
too? I'll. Send me too, please.
Okay.
Thank you, sir.
Okay. Bye. Good night, guys, and all the best
Okay.
for the exam.
Thank you,
Okay.
sir.
Bye.
Thank you for the session, sir.
Okay.
Thank you
Bye.
so
Thank you,
much,
very
sir.
much, sir.
Good
Thank
night,
you
sir.
very much.
Bye. Good night.
Good night, guys.
Yeah, good night, buddy.
Good night, sir.
I already mentioned my mail on chat box.
I also shared like
Ankit, if you get that, please share in the group.
okay, I will share as soon as I get the mail.
Mm.
Okay. Good night.
Hello, Ankit.
Yeah,
So I have shared you.
just give me a second checking.
Can you confirm?
Yeah, just give me a
One more
second.
person.
Yeah, I have received PDF. Thanks.
हेलो अंकित अंकित भाई, तो मैं अपना लिंक वहाँ पे पेस्ट किया हूँ, उस पे तुम शेयर कर सकते हो क्या?
कहाँ?
हेलो,
अच्छा,
यहाँ
मेल फॉरवर्ड करना है कौन से?
यहाँ पे मैंने अपना पेस्ट
या
एक्सप्लेन।
विशाल, अब क्या कह रहे हो आप?
भाई मुझे भी वो स्लाइड सेंड कर सकते हो क्या?
या मैं कर देता हूँ, फॉरवर्ड कर देता हूँ मेल से, फिर व्हाट्स
मेल
ग्रुप
से
में
मेल
हो
से
आप?
मेल से ग्रुप में आई थिंक आई
मेल एक
एम।
बार शेयर कर दो।
मेल आई हैव राइटन इन द चैट बॉक्स। वेयर?
या मेल एक बार सेंड कर दो, मैं वो फॉरवर्ड कर देता हूँ।
वेट वेट वेट। हेलो, यू गॉट इट?
हाँ, just a sec sending. Yeah, Vishal, check it. I have forwarded you.
ओके, थैंक यू ब्रो।
Okay, well.
ओके ब्रो, गुड नाइट।